To give a better sense of urgency, let's add a blood screen to indicate our health levels. This is especially good if you don't have this UI in the bottom left, like I was talking about earlier. It might be a good idea to leave it out. A blood screen is a great way to let your player know that they need help. So I've created a blood texture, which you should replace with your own, just really quickly in GIMP. And we can import that now. So let's go into textures and import, and once you find where you've downloaded it, just click it and hit open. Now we need to make this blood screen here a material so we can alter the intensity of it coming into the screen. So let's go into content, materials, and we're just going to create a new material. So right click, material. We're going to call this M blood screen and open it up. Now this material, we need it of type post-process because we're going to be adding it to something that the camera processes. So in material domain, if you have this selected, in material domain, change this to post-process right here. So it changes it from a surface type to post-process. And you can see we now only have one input right here, and that's the emissive color. So what we need first is right-click, scene texture, and we want this scene texture, the ID, to be of type post-process input 0. We need to take the color here. We need to mask it, so we'll search mask. We want this component mask right here. It's going to be right above the one that's automatically highlighted. And over here on the left, we want R, G, and B all to be selected rather than just R and G. And we need to lerp this. So search lerp and choose linear interpolate. And out of the B, this is going to be our blood texture. So let's hold down the letter T and click. This will create a texture sample, or you can just right click and search texture sample. This one right here. And the texture we want is this blood texture we just imported. So just search for blood screen border. And we need to multiply it by an amount. We need to let it know how much on the screen it should be, if that makes sense. So for testing purposes, we are just going to use a constant. So let's hold down 1 and click. If you hold down the 1 key and click, it creates a constant, or you can just search for constant, the one at the top. And we want this number to kind of affect the entire radial gradient. So we want it to come in from all different sides, kind of like a circle. And we luckily there's a node for this called the radial gradient exponential. And this number will act as our radius. So we can just plug that into radius. Now we also need a density. So let's hold down 1 and click again. And this number will be our density. Now we want to be able to adjust both these numbers in any material instances we create. So let's just right click on this and convert to parameter. And we can now name it. I'm going to call this one density. This makes it so if we make a material instance, this is now something we can adjust in that instance of the material. This allows us to create multiple materials and slightly alter things how we like in separate instances. I'm going to make the default value of this 10, not 0. And I'm going to make the default amount of the radius 1. And we want this to be a parameter as well, though we will be switching this out for something later. But this is just to do some tests. So we'll just call this amount for now. I guess we could have called it radius. It doesn't really matter. Now we need to multiply these two together. So out of the RGB, we can get a multiply node. And for the B, we want this, except for the fact that this is currently inverted. This will be creating a circle on the inside and expanding it outwards, while we need everything on the out to be our texture expanding inwards. So we do this with a 1 minus node, and then we can just plug that into the B. Now this multiply will go into the B of the lerp, and for the alpha, that'll also just be this number right here. Let's create a reroute to make this easier, and this is our result. You can save and it'll apply automatically. And what we need to do is take this blood screen, right click, and we're going to create a material instance. And we could just leave it as blood screen inst, and I'll show you now that we can check amount and density, and we can change these numbers accordingly. In order to see this, let's just add it to our level, which will be viewable with our camera. And we just need to find our post process, which I put over here. If you don't know where it is, you can just search for it in our world outliner. And we need to add it, if we search for post process, we need to add it to our post process materials. So we have this array, it has no elements, so we have to add one. We can choose between these two. We want an asset reference, and the asset we're referencing is this blood screen inst. So we pull it in, and we don't see anything yet. We hit play, we don't see anything. But if we go into the inst and we adjust some of these values, let's make the amount 0.5. You can see it's starting to come in. If it's 0, it comes in all the way, but you can see that's an issue right there with the black in the middle. We'll just change this to 0.5, and let's make the density something like 5. The density will change kind of how smooth this edge here is. See, if you make it 100, it's very sharp. If you make it 0, you don't want 0 because that just won't work at all. 5 is a good number for me. And you'll see the same thing if we go into our world and we hit play. We now have this kind of blood that comes in from the left and right. When I created the blood texture, I made it quite packed around the edges. We can see in the textures, it's really red around all these edges. So if you want something lighter, just like blood splotches, you make sure to keep that in mind when you're making your own assets. Just have kind of splotches here and there. Now we need to be able to change this amount variable in our blueprints, and we can't really do that with just a parameter right here. So instead, we're going to have to make something called a material parameter collection. So let's go into content and materials. We'll just put it in here. I'm going to right click, and it's under materials and textures, and we need this materials and textures, material parameter collection. And we'll call it MPC, material parameter collection, blood screen. We can open this up, and this, we can ignore this vector parameters here, but these scalar parameters, these will give us adjustable numbers if we add one and open it up. Basically, in the exact same way, we have these parameters right here. These are also called scalar parameters, by the way, when they're numbers. When they're just the one number, I mean. So it's essentially the same thing in here. So we can also name it. We'll just call it amount as well, and we can give it a default value of 1. Same thing as this one. And we just need to switch these out. So we can go into blood screen, delete this amount right here, right click and search for parameter collection parameter. It chose MPC blood screen for us by default, but if it's not there, you just open this up and you click on MPC blood screen, and we can choose the parameter that we want to use. We have amount here. If we were to add more, it would give us more options. So if we were to add another one, leave it as scalar, we can now see. Oh, we have to compile these all, of course. Well, maybe I have to refresh it. Just delete it and create it again. Parameter collection parameter. There we go. Now we have both. It's a little too much hassle just for that example, but it's fine. We just can delete this one now by clicking on this little arrow and hitting delete. So we'll choose amount, and we will plug this into the radius, and it's essentially doing the exact same thing. You'll see our ints now only has our density, which we can change to your will, and this amount, it can now be controlled from the blueprints the way we want it to. And we want to do that in our BPC health. So we'll go into content. Sorry about that. We'll go into content, blueprints, components, and BPC health. And we'll just make this with the function. We'll call it update blood screen. And in here, we will set scalar parameter value. So the value we need to set, obviously, is from the amount, but it needs to know what collection it's from. So we can just choose the NPC blood screen collection right there. Now it gives us this option to choose amount. We'll choose that. And now we can adjust the value right here. That's how we adjust our value between 1 and 0, or whatever you'd like to have. I'm going to do it between 0.5 and 1 as... Oh, well, right, we can't see it anymore, but 0.5 was the maximum intensity I would like to have. So it'll be between 0.5 and 1 for me. And we'll do this with a map range. And we want it clamped. I explained this a couple episodes back, so I'm not going to spend too much time explaining it again. But the value will be our current health. And for in range and A and B, we want minimum health and maximum health. And then the out range will be 0.5 and 1. So 0.5 is connected to minimum, so if we're at 0 health, it's at full intensity. Maximum health, it's at 1, which is no intensity. Now in add health and remove health, we just need to add in the update blood screen at the end. So after add health and after remove health. And we also want to add it to the begin play, just in case you want to start out with not full health, which we are doing right now, which I mainly just do for debugging, but in most games I think you would want to start with full health. So we can hit play, and we'll see since we're at 75% health, we kind of have this red circle outline around the very edges, a little hard to see, but if we slowly start to take more health off, you can see it is starting to deplete. So just like that. Now if you don't want the blood to start showing up until we're at a certain percent, say you want no blood on the screen until we're at 70%, so let me hit it once, we're at 73, we've added a little blood on the edges, it's pretty faint, but say you don't want it to start at all until you hit 70%. The way you would do that is going into BPC health, update blood screen, and you just need to get the max health multiplied by the number you want, the percent you want. So if we get our max health, get a float times float, put it in the in range B. You just want to make this number the percent you want it to start at. So if you want it only to start at 70%, you multiply it by 0.7. And that'll work. Except one more thing, if you remember our min health here, if you want to adjust this to be something other than 0, this will once again mess up your percentage. And the way around this is taking our max health, subtracting our min health, and then multiplying it by that number. So we're going to do that just in case we ever want to mess with our minimum health number. This will reset the percent, and it will be correct no matter what these max or min health values are. So now if we hit play, I'm going to hit 2. Oh wait, I just realized that we don't start with full health. Let's start with full health first. So let's go into our BPC health, current health, and let's make this 100 to start off with as a default. So we hit play. We have, if you look in the bottom left, we're at full health. We have no blood on our screen. If I hit the number 2, which is going to take off 27, we're at 73, and we still have no blood on the screen. Once I hit 2 again, the blood has now started. We're at about 48 health, if I remember correctly, and we have this faint blood as an outline. around our screen. We do it again, and it doubles in intensity. And that's how you add a blood screen for your game. Alright, so let's get working on hiding. The main point of hiding is a way to escape from our future AI's wrath. You could create this method where the character hides manually, as in they open the locker door, walk in, and have to close it again. But we're going to create an automatic version where they walk in and close the door after just interacting with it. As you could easily do the first version with only the logic from when we created these doors, but we want to make ours a little more automated. Alright, so I made a quick locker in Blender, so we have something to hide in. We can import it for this project. It's something you're going to want to replace for your own project, but you can use it for these tutorials. So let's go ahead and import that. So let's open up props and meshes. We're going to import it right here. And once you've navigated to where you've downloaded our two FBX files right here, we have a locker and a locker's door. They're separate objects because we need to be able to open the door. So let's hit open. And they will not be a skeletal mesh. Auto-generate collision is fine for now. Everything else looks good. So let's hit import and import again, or you can just hit import all if you want all the settings to be the same. It's going to create two materials for us. We only need one material because we're going to put the same one on both. So I'm just going to delete material 02, force delete. And let's open material 01, and I just want to make this look a bit more like a locker. So we're going to make it blue, and we're going to make it a little shinier. So let's just take this color here, let's make it a nice dark blue, maybe something like that. And we want to up this metallic input right here, so we're going to use a constant. So if you hold down 1 and click, or right click and type in constant, it gives us a value, which is just a float, and we're going to make it 0.8 because it is a value between 0 and 1. Plug that into the metallic, and it's a bit shinier now, looks a bit more like it's made of metal. You can mess around with it more. It doesn't matter too much, as you should be replacing this with your own object of whatever you want your player to be able to hide in. But maybe we could even take this roughness and not 0, but 0.4. I don't know, I'm just kind of experimenting right now. Looks good, so let's hit save. And back in here, it applied it to our locker door. We need to assign it to our locker as well. See how it looks on the door. Yeah, it looks fine. And on the locker, let's change the material to, oh, we didn't name it. So let's go back and rename material 001 to matte, or I think it's M, that's how I do it, locker. Open up the locker again, and we will assign this M locker. Alright, that looks fine. And in locker door, we could put it for the second material right here if we want. Or we can make that some kind of separate, let's see, let's bring this material out of the meshes folder and into the materials folder. So if we click this icon right here, it kind of shows us this layout, and here we have our props, and we're inside meshes. We want this inside materials, so I'm just going to drag it, move here, and now it's in our materials. I'm just going to take this battery texture, and I'm actually just going to use it on this little front part here, just to, so we don't have to make another. Actually, I honestly hate the look of that, but it's fine as this is just a tutorial. Yeah, I'm going to change it to M metal instead. Definitely spending too much time on trying to make this locker look good, even though it's just for teaching you how to do this, but we're all done now. I'm going to collapse this again because I like it closed. And we're ready to get started. So let's go to our blueprints, and we're going to need to create a blueprints for actors we can hide in. So blueprints actors, and we need a new category, a new folder. And so right click, new folder, and we'll call this hide actors. And we're going to use the same method of creating a parent class and children so that you can create many different types of places where your character can hide. So let's open this, and let's make an actor. Right click, blueprint class, actor, and we will call it BP hide actor. We can open it up, and I'm just going to close all these meshes right here. And we need a few things. We need a static mesh. This will be just the mesh that we're hiding inside. And we also need 2 arrows. And I'm going to call this arrow player position. And this arrow exit position. Now we don't want this arrow as a child of player position, so just drag it on top. So none of them is apparent. And these arrows will decide the place that we want to move our character to when they hide, and then when they exit hiding, since it'll all be automated and you don't walk in yourself. Once again, you can have it like that, but you would just need to follow the door tutorial, as that's all you would need, as long as you have a mesh that you can walk into and out of. So let's make a child actor of BP hide actor. So let's right click on BP hide actor, create child blueprint class, and instead of child, we'll call this locker. BP hide actor locker. Let's open that up. Now this static mesh right here is going to be our locker. So you can search for locker. There we go. And we also need a door on our locker. So in this one specifically, we're going to add a second static mesh. And we're just going to make it a child of the inherited static mesh from our parent class right here. And this will be the door. So search for locker again, and we'll just do locker door. Now we need to reposition this locker door so it's actually at the right spot. I've already done the math of what location that needs to be at, so you can just copy these values. If you made the mesh yourself, then you should already know the values, and if you buy a mesh, then you're just going to have to fiddle around with it until it looks good. But for this one, we have negative 37.5. Oops, I put 2. Negative 37.5. There we go. On the Y, 39, and Z is 0. Now we also need to reposition these arrows. We need to put them where we want our player to be hiding and where we want our player to exit once they leave the locker. In terms of verticality on the arrows, we need to put the arrows at the same half height as our player capsule if you want your player not to move up or down. So let's go to content and game PP level 1 L1 character, and right here under capsule component we have capsule half height, and this is just half of the length of this capsule right here. So see this blue arrow? We need those other 2 arrows to be at the same Z axis as this blue arrow, or when your player moves, he'll move up or down, and we just kind of want him to go straight into it. So our player half height is 88, so we can take our player position, make the Z value 88, and we'll do the same thing with the exit position. So now let's reposition these. So for the exit position, I'm just going to pull this out for a minute. And for this door, I am just going to hide it real quick. So just visible. Just turn that off for a second, just so I can see this. It's already dead center inside the locker, so I'm going to leave it like that. And I'm just going to rotate it 90 degrees. So it tells us which way we should be facing. And I want to be facing, I'm going to make this visible again. We want to be facing towards the door so we can kind of peek out of these things right here. For the exit position, when we come out, I also want us to be facing this way, so I'll rotate this 90 degrees. And a good length I found is making it the y-axis 200 when they come out. That's a value I like. This will obviously be something that you just adjust based on what you feel you need. Now, so we need to be able to interact with this locker so that we can enter and exit it. And it's been a while since we used it, but we still have our BPI interact, or our blueprint interface, and we can just add that to anything we want to be able to interact with. So if we go to our class settings right here, implemented interface. Oh, we're doing this in the parent class, by the way, so every child class will have the same interface. We want to add BPI interaction. And now, if you remember, in our L1 character, which I'm just going to compile real quick, in our event graph, when we hit, I'll have to find it, we should probably organize this a bit. When we input action, we're checking to see if we hit something with the BPI interaction interface, and if we do, it calls the interact event. So now that it's been implemented into our actor, we can now call this event. So let's do that. Let's go to the event graph. Here on interact, just right click and implement function. And we need a reference to our player character. So let's get that in the begin play. I'm just going to delete those two, bring this up a bit. So in the begin play, let's cast to L1 character. Object, as always, is get player character. And let's make this a variable. Player ref, as always. So when we interact with it, we want to move the character into our hiding spot. No matter what our child hide actors are, no matter what kind of hiding place they are, in every single one, we do want to move to this player position. In the locker itself, we're going to add some code to make sure the door opens first, and then we go in, and then the door closes, but that won't be universal to every single hide actor you might make. So in the hide actor itself, we'll add the moving, and then in the children, we'll add any extra necessary steps we need. So let's make a custom event, and we will call this move character. And we'll just pull this, and basically we have to do exactly what it says and just move our character. So we'll get our player ref, and we will set the actor transform. And it's this one right at the bottom, set actor transform. And our transform holds our location, rotation, and scale, even though we will only be messing with the first two. So let's split this. So we have our location, our rotation, and our scale. So we want to set the location by interpolating our character from its current location to the inside of the locker. And we can do this with a v-interp, which is a vector interpolation. So we can search v-interp, and we want a v-interp to constant. A v-interp to constant will reach this target at a constant rate, while a v-interp to, the regular one, gives it a smooth feeling when tracking. But I feel like this actually doesn't work as well when doing kind of a hiding function, because it's supposed to feel like it's being done in a haste. So when you kind of ease into it and then ease out when you get into the locker, it feels a little too nonchalant for me, and the constant feels a lot more rushed and hurried, which is why I like the constant. So for the current location, this is just our player rest location, so we can get actor location. And the target is our player position. So we can drag this out, and we will get world location. And this goes into our target. And the interp speed, or how fast it goes, we're going to set this to 1000, which is a pretty hasty speed. Lastly, for delta time, we need to just get the world delta seconds. Now, a interp node needs to be called every frame for it to run smoothly. You can't just call this once, or it'll move you for one frame and then stop. And we'll do this with a timer. So when we interact with our object, we want to start calling this move character every frame. So first thing we want to do is take our player ref and actually set its collision to false. This way it doesn't get stuck on our locker, and that could create a lot of bugs. So technically when it's inside the locker, our player doesn't have any collision. So we want to set actor collision, enable collision, and we want to set it to leave it as false, so it turns off our collision. And then let's just call our move character timer by event. So, or set the timer by event, sorry. So set timer by, now we've usually done set timer by function name, which you could use, but in this case we're just going to set timer by event, because sometimes when you're using an event, it's just a little cleaner just to plug in this event to there, and now it knows what timer to set. I should mention though that set timer by function name also works if you type in the event into the function name. So if I were to type in move character right here and plug it in like that, this would also work. But we're just going to do it like this. So the time, we want it to be every frame. So we will get the world delta seconds. And looping is true. Now we can actually test this out now to see if it works. So let's go ahead and come in here. The map's getting a little crowded here, so how about we take this, I'm going to hold down Alt and drag, that duplicates it and drags out a new one. Change this to unlit so we can kind of see what we're working with. I'm just going to drag it out like that, and drag this out. We're just creating this big old hallway. And then take these three, and I'm going to hold Alt, drag, and we're just expanding our room to add more things. Alright, now let's change this back to lit. So it's going to be a little dark back here when we build the lighting, so I'll hold Alt with these lights again, bring them over here. And let's just build lighting only, so this doesn't kind of have this weird gray line going on. Alright, so let's add our locker in to this scene. So blueprints, actors, hide actors, and we have our locker. Let's kind of put it in the light over here. And what should happen now when we interact with it is our player will lose collision. We won't really see that happening, except that it'll go through the door, and we should just move right into the middle of the locker. So let's hit E, and there we go. We've moved into the locker. You can kind of see out. We can't really move anymore, and we're kind of stuck in here forever. And it's constantly calling this move character event, but it's definitely a great start. So let's start with the most obvious thing, is that the door doesn't open or close. We just phase right through it. Second, as I just mentioned, our timer is still firing every tick when we're inside, so it's always updating us to force us into that position right in there. So let's kill the timer once we're inside. So let's go to BP hide actor, and after we set the actor transform, which we're doing every frame, we just want to check to see if our player location is at this new arrow position. So we'll get a branch, and we just have to get our player reference, get actor location, and then our player position, and get world location. And we just have to make sure that this player ref's location is at this world location. So we'll get an equals equals, and we have this equal and equal exactly. We want the equal because equal exactly is risky to use, and if it doesn't get perfectly spot on by 0.00001, it won't work. So let's get this equal, and we can change the tolerance. So this is how close it has to be to this vector right here, and I'll actually just change this to something like 0.01. So we'll still always be in the same position, but it will always make sure that we did make it. So let's plug that into the branch, and if it's true, we want to clear this timer. And we do this with this return value here. So if we pull this off and type in clear and invalidate timer by handle, this is the node we use to stop this timer when it's set timer by event. So let's break this execution, because we obviously don't want to do it right after we set the timer. We only want to do it once we've reached our location. All right, compile and save. So now let's print a string to say moving character to show us that we've stopped. So let's go to the locker and let's hit E, and it'll say moving character, and it should go away now that we're inside. No longer calling that tick, no longer using up unnecessary space. So we want to do more than just disable the collision. We want to disable our movement as well. We don't want to be able to quote-unquote walk around the locker, especially because it's no longer moving our character. And I should have demonstrated that, so let me actually do that now. I'm going to move our player, since we're going to be working with this a while, I'm just going to move our player start right here, make us face the locker. Let's play again, and let's go to our locker, hit E, and now if I kind of try to walk around, we're still pretty stuck, but in my testing I could see that it could create bugs, things could get kind of jittery. Right now it seems to be fine and doesn't seem to have any big issues, but just for safety's sake, let's disable our movement when we're inside this locker. So in BP hide actor, before we set the timer, when we turn off the collision, we also want to disable our movement. So let's get our player ref, and we'll need to get our character movement from here because that handles all our movement, and we will disable movement. And now it won't look any different, but our movement doesn't register when we're inside the locker. All right. Last thing to do in the hide actor for now is adding a way to get back out of the locker, because we get in, but now we can't get out. So we need to create a Boolean in our character, actually, for if we are hiding. So let's create this. We'll call it is hiding, because I want this to be known in our character and not in our hide actor. So let's go back to our hide actor, and now we can kind of do a flip-flop between hiding in the locker and getting out of it. So we're going to pull this out, and we're going to create a branch. And we just need to ask if our player is hiding. This is the new Boolean we just created. If we are not hiding and we interact with it, we want to follow this logic. So we're going to move this to the false node. I'm just going to pull it all down since we need to add stuff to the true. You as well. All right. But if we are hiding and we interact to get out of the locker, we actually want to set timer by event. And we're going to use this same move character event. And we're just going to change things up a bit in here to decide whether to move us in or move us out of the locker. It saves us from creating two separate events, since they would be mostly identical for the most part. So it will set the timer for the same event. The time will be world delta seconds, and it is looping. And at the end, when we finish moving, we want to clear and invalidate this timer as well. So we'll get this, clear and invalidate timer by handle. We don't want to do it right after we set the timer, so we're going to break that. And we're just going to pull this back here, and it's going to invalidate both, even though it'll only ever be using one. It'll just invalidate both, just so we don't have to create unnecessary if statements to decide which to invalidate. Now this still is technically invalidating moving out of the locker once it moves to the interior player position, but we'll fix all this up so it knows which to move to. So let's actually do that. So the first thing it does is set the actor transform by V-interpolating it to our player position. We need to decide if it's moving to the player position or the exit position. And we can do this with a simple select node. So we're going to get the world location of one of these with a select node. And the wildcard, or the index I should say, is our player ref is hiding. So just get our player ref, ask if they're hiding. If they are hiding, we want to go to our exit position because we're leaving. And if they aren't hiding, we want to go to the interior position. So they start hiding. We'll do the same thing over here because we have to ask whether we've reached our player position or our exit position. So same thing, get a select node. I'm going to copy and paste the player ref is hiding. And if we are hiding, we want to ask if we're going to the exit position. And if we're not, the player position. And I want to reiterate, player position is just the hiding position. We should probably rename it to that so we don't get confused, because it's not the current player position. We can call it hiding position from now on. So now, no matter which one we're doing, when we finish, both timers are invalidated, even though one won't be going off. So I think we can actually test that right now. Hitting E on it, we've gone inside. If we hit E again, we do not move outside. So I must have missed something. Let me figure out what that is. Oh, of course, the reason this doesn't work is because we never actually changed this Boolean is hiding. It's false by default, and we never change it to true, so it doesn't know to switch to the next part. So we can do that by creating a custom event, and we'll call it finished moving. So this will be called once we've finished moving. And we just need to ask if we're hiding. And if hiding was true, we need to set it to false. And if it was false, we need to set it to true. So check it for this one. We're also doing this in the finished moving custom event because I don't want us to be officially hiding or out of hiding until we are fully in or out of the locker, instead of right when we interact with it. This can be useful for when we implement AI, so that if an AI is chasing us, for example, and they can see us, say they're right there, they see us when we click going into the locker, since it'll automatically change to is hiding even before I'm inside the locker, that can mess up some of our AI logic because they now think we are hiding when we should still be in plain view. That's why we're doing it after it's set to finish moving. Once we've stopped hiding, so we set is hiding to false, we also want to re-enable the collision and re-enable the movement, obviously, so we can move around again. So let's just get another player ref right here. And let's set actor enable collision. And we want this to be true. And then we can get our character movement. And if you remember, I mentioned this in a previous episode, there is no just enable movement node. We need to set the movement mode to walking, which is the one we use at all times. It's also the default movement mode in character movement. So after we clear and invalidate these timers, we're going to call finished moving, and we can test this out. Now we can see if it works and let us go back and forth. So we're going in, we are now in, finished moving has been called, we no longer have collision and we cannot move around. We hit E again and we've been moved outside the locker, and enable collision has been re-enabled, and we can walk around. So we can just go in and out, back and forth, So now that our hide actor works the way we want it to, we need to adjust the locker itself so that it opens and closes the door accordingly. And we're going to need to create an event dispatcher in our regular hide actor so that we can reference it in our locker. So let's create an event dispatcher, and we're going to call this finished moving ed for event dispatcher. And after we finish moving, we're going to call it, or right before we do everything else. So just drag it out and then hit call. And I believe I've explained event dispatchers in a previous episode, but essentially they work similar to interfaces where this is called and we can assign it in other blueprints, and every time this is called, it will trigger in the other blueprint. So in our BP hide actor locker, we need to create a, in the interfaces, we need to implement the interact function. Now let's right click on it and add call to parent function. Now the way this works is when we interact with the locker specifically, we have this parent interact, and everything inside this parent interact node is everything we have in the parent after interact is called. So all of this is in this little node right here. Now by default, when you don't have these two separate, it does this all by default immediately. But now that we've created it separately, we can choose to do things first and then call this, such as open the door and then move our character. Now if you see, we don't connect these at all because we created them separately. If we try to interact with our locker, nothing happens because this parent interact is never called. If we plug it in, once we interact with the locker specifically, the parent interact will be called and we can move in and out. So let's break this again, because before we call the parent, we need to open the door. And we'll do this with a timeline the same way we open all these doors over here. So let's create a timeline, and we'll call this open locker door. Open it up. The length is the amount of time it'll take for the door to open. I'm going to say 2.25, so a fourth of a second. And we need to create a float track. And we'll call this float track alpha. And this is just a 0 to 1 graph we'll make. So let's just add the two keys. Time 1 will be 0 and value will be 0. Time, we want this to be at the end of the length, 0.25, and a value of 1. So it takes a time of 0.25 seconds to go from a value of 0 to 1. And we can select both of them, right click and change this to auto for a bit of a smoother opening. If you remember me talking about the vinterp2 and the vinterp2 constant, this is a good visual difference. This is the vinterp2 where it kind of smooths in and out, but if we were to change this to linear, this is the constant. It goes at a steady pace the entire time. But for a door opening, it almost always looks better when you've got this smoothing. So back in the event graph, we have now our updated timeline, and we just need to use this alpha to open and close this locker door, which is our static mesh 1. This one right here. So I'm just going to move this parent interact over here, because we'll come back to it later. And we can get our static mesh 1, which is our locker door, set relative rotation. Now we've done this a few times since we made 3 different types of doors. I want to plug it into the update. And the new rotation, we only want to rotate on the Z axis. So you see, that's how we open it. So let's split this. We have the Z right here. We'll use a lerp, which is a linear interpolate. And the alpha will go into the alpha. So this A float right here is equal to 0, and this B is equal to 1. So it will follow this graph right here from 0 to 1. And our door being closed is at 0, and then when it's open, we want it to be at 90. So let's plug that into B, 90. So now we can actually even show you how this works. Our parent interact is never called. So when we interact with the locker specifically, it just opens the door. That's all it'll do. So once this timeline is finished, we can then call our parent interact. So it'll wait for this timeline to be done. It'll wait for the locker to open, and then we will go inside. So we can test that out again. We can watch, open, then we go inside. And that looks a lot better so far. And if you want, you can add a small delay after the timeline to give it a bit more of a natural feel. So we don't go in literally the same frame that the door finishes opening. So maybe like 0.1 seconds. And can try it again. And there's just that tiny little delay before we go in. I think it makes it look more natural, more human. So now we need to be able to close the door once we go in. So let's create a custom event. And we'll call this close door. And right before we continue, I just remembered we want this to play from start instead of just play. And this will just ensure if all these are play from start, it will all go smoothly and it won't ever get stuck in the middle somewhere, because we're going to need a second timeline for closing the door. So we're going to copy this and paste it, play from start, and we can just call this close locker door. But we don't need to change anything on the inside because we want it to be the same length, unless you want it to be slower or faster for some reason. And we just need to copy all of this. So we're setting the rotation, alpha, and we just need the A to be 90 and the B to be 0. That way, instead of opening, it closes. Now we need to know when to call this closed door. We don't want to close the door until we're fully inside the locker. But depending on how far away or close to the locker we are when we interact with it, can alter the time it takes for us to get inside the locker. That's the main difference between timelines and interpolation. Timelines will always take the same amount of time to do the same thing, while interpolations is interpolating from one spot to another, which can change how long it takes depending on the distance between those two things. Which is why we've created this event dispatcher. We have this finished moving custom event, which is called once we've finished moving. So it's perfect to use this event to know when to close the door. So we created this event dispatcher, and now we need to call it in the locker. So every time this dispatcher is fired, we can close the door. Or we can close the door when we go into the locker every time this is called. So in the event begin play, I'm just gonna delete these two right there because we don't use them. Oh, didn't mean to do that. Let's just bring these up. After we parent to the begin play, I can't remember if we actually have anything in our begin play. We do, we set our player ref, so we want to keep this parent right here. I'd keep it anyway just to be safe, but it's good that we know. And we just need to assign this event dispatcher. So we can search for finished moving, but we don't want this finished moving function. That's the event that we made. We want the finished moving ED, event dispatcher. And we have all these different options. And what we want to do is assign it. This creates both a node and an event. And we can call this event. Yeah, we could just leave it as that, or let's take out that 0, but we can just call it finished moving ED event. So every time that this finished moving event dispatcher is fired, which is called every time we finish moving, this custom event will be called in our locker. And that's why event dispatchers are powerful. So after we finish moving, we just want to close the door. So we can call this event we just made close door. Caps lock is on. But once again, if we want that more natural feel, I'm going to give it a small delay of 0.1 seconds so it doesn't happen the same frame that we finish moving. So let's see how that looks. So it's open, it closes when we get inside. Perfect. And it closes when we come back out as well. Look at that. We can now hide in a locker. Now let's fix this small bug that you might not have noticed, but it kind of happens if you start like spamming your action button. So if I you can see, we don't want this. We don't want this happening. That's pretty ugly. So we only want to be able to interact with it when we're not in the process of moving in or out. So we need to disable our ability to interact with the locker specifically when we're running through all this code. So we'll create a Boolean for this, and we'll just call this can interact, and we want to set it to true by default, because we want to be able to interact with it by default. And in our locker, when we interact with it, event interact, we first want to check if we can interact with it. So let's just get our can interact Boolean. Once again, if you don't see these variables on the side here, you need to check show inherited variables right there. So if can interact is true, then we can continue. If it's false, we don't do anything. But if it's true, we also want to set can interact to false immediately. So it continues. We can't interact with it until we finish, which I want to be after the door closes. So after close locker door is finished, set can interact back to true. So this no longer gives us the ability to interact with our locker while we're moving inside or outside of it. So now if we spam the action button, it just plays out the way we want this to. Perfect. There's one more bug to address. When we open and close our inventory, when we're inside the locker here, I'll show you, a lot of parameters get reset. If you remember, right now we've just disabled our collision and our movement, but opening our inventory also disables our movement. But then when we close our inventory again, it re-enables our movement, and that can screw things up. So if I show you, if I open my inventory and close it again, actually, we've gotten pretty lucky, nothing's happened, but kind of like the last issue, when our movement is actually technically now enabled, and that can create bugs, things can get jittery. I've definitely fallen through the floor at least one time while trying to test this out, and we don't want any of that happening. So we will go into our GameBP HG player controller, because this is where we open and close the inventory. Toggle inventory, and we want one more if statement, create a branch, and let's promote this condition to a variable, and we will call this can open inventory. If we compile, it's we want the default to be set to true. We want to be able to set it, and we only want to be able to open the inventory if it's true. Now if we go to our hide actor, our master class, in the begin play, we can cast to HG player controller. Object is player controller, get player controller, and we can just promote this to a variable. We'll call it controller ref, and we just need to set when we can open and not open our inventory. So we don't want to be able to open it once we're entering our hidden object. So if we're hiding, if it's false, and we're going in, we set our actor enable collision to false, we disable the movement, and then we get our player controller, and we set the can open inventory to false. Now we need to reset this back to true once we're out. So we do this at finished moving, custom event, and at the very end, after we've re-enabled our collision and movement mode, we set can open inventory back to true. And now if we press play and we go into our locker, we can no longer open our inventory unless we leave. All right. Well, that's everything about how to create a hide actor. We've designed it in a way where you could easily make more, and just remember the rules about when to call this parent interact when you interact with the children. Some things won't need anything. Some, if you're like hiding under a desk or something, you can just call the parent interact, and that'll be that. But yeah, everything works well, and we can now have a place to hide from our AI that does not exist yet. So what would a horror game be without a few lock puzzles? Every good horror game has some lock puzzles. In this episode, we're going to be creating a simple combination lock with 4 different dials, and you have to put in the correct code in order to unlock the lock. But the logic of how we create this lock should help you put you in the right direction of how to create puzzles in general. So we need to import the lock first. I made a quick lock mesh in Blender. I've been making more and more complex meshes as we go along that you can replace with your own. When you're getting your own lock, you want the lock itself and the dials to be separate meshes because the dials will turn independently. But let's just import that now. So let's go into props and meshes, and let's hit import. And once you've found where you downloaded the lock, we have these 5 FBX files right here. This lock and lock dial, those are the meshes that we'll be using. This box and box top, this is just a quick chest mesh that I made for something to actually put the lock on. It won't have any functionality. I just wanted something to put the lock on. And the lock open right here, this is an animation I made for the lock opening. So first, we're just going to import these 4 so we don't get overwhelmed. So hit open, not a skeletal mesh, auto-generate collision is fine. The transforms are all good, and create new materials is fine. And let's hit import all, so all will import with those same values. So it created our materials here, and it imported a texture. So one of my materials had a texture on it. So first, let's just go over this box. I just have a hollow box, and then a top for that box with a little latch I just created. I don't know, I got a little carried away. I was having fun. And then we have our lock here. Oop, focus in on it. There we go. And our lock dial. And this one's very small. There will be 4 of them on our lock. And this one has this material right here, but that I believe is a Blender material that I use that's just a part of Blender to set the UVs up correctly, but we'll have to change it. So let's see what the box uses. It uses material 6, material 7. I'm just going to make it those the same material. So I'm going to delete material 7. And I'm just going to take material 6. We can make it some kind of brown color. It doesn't matter too much. I didn't make a material for it when I made it in Blender. So let's just kind of maybe like a dark brown like that. Oh, it's a light brown for sure. How about a dark brown? Okay. And you can obviously mess this around with as many things as you want. Turn the roughness up to like 0.9. Sure, that looks fine to me. So box, and seems like box top. Oh, that's because material 7 was not for the box top. It was for this latch here. Can't seem to focus on it though. So that is my bad. Sorry about that. We will need a material for that. So it's just going to create it. We call it M box latch. And this can be, I don't know, this can be white. I'm going to hold down 3 and click. This will give us a 3 vector, which can create a color. Just going to make it white for now. And that's fine. I don't need anything else. And then in the box top right here for our element 1 material, I will search for box latch, and now it's white. Let's rename material 6 to M box, and those are good to go. Now let's change the color of our lock. Our lock also has 2 materials. One is for this this top part here that will be metal. This one I'm just going to make it a solid color like I've done with everything else. And that is material 3 and 4. So let's take 3, which is the metal one. And here on this metallic, we can hold down 1 to create a constant. Click. And let's go to 1 value of metallic and see how that looks. Okay, maybe bring the color of this down. It's a bit more of a gray. Sure, yeah, that looks good to me. And yeah, that looks good. And material 04 is the solid color. We can make it kind of an orangey. Let's see. It's a little bright. I'm gonna bring down the darkness, and that looks fine to me. I mean, you can mess around with you want, create a couple constants, maybe make it a bit more metallic, like 0.7. Bring the roughness up a bit. Whatever you want, that looks fine to me. Just gonna save and compile. And yeah, I like the look of that. So we will call this M block metal and M block body. Now for material 5, it's got this texture on it, but this is, like I said earlier, this is not the correct texture. This I created in Blender, I believe. So we're gonna have to replace it. And I actually did create a texture for this. I think I just forgot to put it in my resources folder. So let's import. And I cut so I could add it to my resource folder, and it's right here, dial base color. This will be in the downloads file for this episode, and we can hit open. And this is just a 0 through 9 texture that we will replace this. So it's called dial base color. So let's just take the texture sample, just search for dial base color, and this is the texture we want. And I'm going to just up the roughness to 0.9, and maybe the metallic to something a little high as well. All right, so we can now, let's hit save all. We can delete this dial texture reference because we don't actually use it, just imported with it. We have these 5 new materials. I'm gonna open the sources panel right here, and in prompts, we're inside our meshes folder right now, but we have these materials and textures folder, so let's move these to their appropriate places. I'm gonna select all 5 materials, drag it over the materials folder under prompts, move here, and I will do the same with dial base color into textures, move here, and that, now we have it. Our dial base color is in there, and our new materials are in here. Now there's actually one thing I realized that I actually made a mistake of. The lock mesh right here, since we imported all of them as static meshes, the lock also imported as a static mesh, but the lock is actually supposed to be a skeletal mesh. The skeleton does not need to be a part of the mesh for our code to work. Actually, the only reason I did it is so I could create an open animation for when the lock is open. We could make it work with a static mesh for sure. It doesn't need to be skeletal, but it wouldn't be able to have an animation, and I just wanted to add one in. So we're going to actually delete the lock mesh and re-import it as a skeletal mesh. So import lock FBX open, and we want to have skeletal mesh checked here. Import mesh checked. Leave the skeleton blank. Import geometry and skinning weights is fine. Import animations, we're going to leave blank because we'll import the animations separately. And we do not want to create new materials since we already have some, so do not create material, and don't import textures even though we don't have any. And we'll just hit import, and now we have our skeletal mesh right here. Bone size is too small to create physics asset, that is fine, we don't need one. So now when we open it, it is a skeletal mesh. We can click on the skeleton tree, and we can look at all these bones. I decided to add dial bones, so it would be easier to place our dials exactly where we need them. And it's already automatically found its materials, but if it didn't, just go to the asset details and add them right here. Alright, did I forget to rename these? I don't think I did, so I don't know why they're called material 3 and material 4 here, but it's fine. I'm just going to replace them. So I want to create some sockets for positioning the dials. And like I mentioned, I made the bones in the correct positions, so we don't have to position these sockets manually. So we're going to add 4 sockets, one under each of these bones. So I'm going to right click, and I'm going to hit add socket. And we can call this Actually, dial bone 1 socket is fine. The socket is way too big by default, so we need to make the size a lot smaller. For some reason I don't have my details panel, so I'm just going to go to Window and hit Details, and now we have our details. You can rename it here. That's the bone name, you want to leave that alone. And we have our location, rotation, and scale. We can leave the location and rotation, that's what I made the bones for, so we don't have to worry about positioning. But the scale is way too big, so we're going to make it 0.05 on all axes. Axes, I mean. Sorry about that. I'm sorry, not 0.5, 0.05. Something real small. There we go. Oops. Let's just duplicate this. Command C, or Control C, Control V, and let's drag it under dial bone 2. And then let's just rename it to 2, and then, sorry, not 20, just 2. And take out that 0. And I'm just gonna Control V again, and Control V again. And let's just rename these once more. So dial bone 3 socket, and dial bone 4 socket. All right, hit save. So now we have our 4 sockets right here, and this is what we will parent our dials to in our actor. So while we're here, let's go ahead and import the animation, just because we're importing everything. I'm going to just start closing all of these except for the lock, since we don't need them anymore. And let's make a new folder for animations. So we're in props right now. So new folder, animations, and we can hit import, and the last thing that should be in your list here is this lock open FBX. Hit open. It's a skeletal mesh. We do not want to import the mesh because we've already done that, so uncheck that. And we need to choose a skeleton, and this is our lock skeleton. Animation length is exported time, and everything else should be good, so we'll hit import. And now if we open it, we can see that's just that little lock opening animation. Just something a little fun that we can play once we've unlocked it, so our player knows that they have succeeded. Alright, so now that we've got all our importing done, let's actually create our actor. So let's go into Blueprints and Actors, and I'm just going to create it outside of a folder since it's just the one. So right click Blueprint class of type Actor, and we will call it BP Lock. We can open it. I'm going to get rid of this default scene root by adding a scene and just making it the root by dragging it on top. And we need to add a skeletal mesh. You can probably already guess what this is going to be. It is our lock. So over here in skeletal mesh, we can click on lock and press F to focus on it, and there we go. Now, our dials are going to be separate actors in themselves. So let's go back into our level 1, and let's right click, and let's add Blueprint class, actor, BP, lock, dial, because these will have their own functionality. So we can open it up, and once again add a scene as the root, and this time we need a static mesh. And this will be called lock dial mesh. Probably should have added mesh onto this one as well, but it's fine. And the static mesh will be our lock dial. This one's very small. You can hit F to zoom in, take a look at it. Our mesh needs to be changed to overlap all instead of block all dynamic. Overlap all. This is so we don't have collision issues when we're trying to rotate our mesh, because it'll be kind of inside these lock sections, I guess I should call them. Alright, well now that we're back in BP lock, let's go to our begin play, and we need to spawn our actors, our BP lock dial actors, in all 4 of these areas. So we'll make a for loop. Actually, before we create the for loop, let's just go over spawning the actor itself, and then we'll add a for loop after that. So let's add spawn actor from class. And the class we want is BP lock dial, which we just created. And then it needs a transform. This is telling it where to spawn, and this is why we created our sockets, so it has an exact location for them to spawn. So let's just split this for now. So we has location, rotation, and scale. Collision handling override. We want to always spawn, ignore collisions. And now that we've gone over that, let's add our for loop now. So for loop is just a regular for loop right here, because we just need to do it 4 times. So first index is 3, last index, or first index is 0, last index is 3. So this is called 4 times. And now, technically, when we play, we won't really be able to see them because it'll be like right inside the lock, but once we spawned into our world, our lock would spawn 4 of these BP lock dials right in the center of the lock, all overlapping with each other. So we need a variable to be able to reference our lock dials. So let's take this return value and promote it to a variable, and we can just call it dials. And we need it as an array because we have multiple of them. So if we, oh, not there, sorry. If we go up here in the details, we can click this and we can change it to an array. It's going to complain because it won't be able to plug into our spawn actor, but we can hit change variable type. Won't have any errors. We just have to break that link right there. And actually, let's just delete that in total. Instead, let's take it out, let's get dials, and what we want to do is add. So we want to add a reference to this actor 4 times, and those 4 times will be the 4 dials that spawn in this actor. So after this, we need to actually set them to our sockets. So we're still inside the for loop here. So we can just get an attached to, oh, sorry about that, attached to component. The target is our lock dial right here. So we can just take the return value and plug it into target. I'm going to bring this up a bit. The parent is our lock mesh right here. And then we have socket name. So we can't just hard code the socket name in, because if we only put 1, then all 4 would spawn in the same socket name. So we need to change it based off this index from the for loop. So we can get a select node, and we're just hard coding this in this way. There's probably a more dynamic way to do it, but we know we'll only ever have these 4, so there's no issue with just typing each 4 individually. So based off the index, we know we have these 4. And we can just write all 4 of them. Now we want to make sure we get the socket names exactly correct. So we can go back into our lock, and we have dialbone 1 socket, dialbone 2 socket, dialbone 3 socket, etc. So just type in dialbone 1 socket. I'm just going to copy and paste this, and then just change this to 2, 3, and 4. Now for the location, we want to snap to target, which will snap it to the socket location. Rotation, snap to target, and scale, we will keep world, so it'll keep its original scale. Oh, I'm sorry, rotation we don't want snap to target, we want keep world as well. We just want it to snap as location. So we can actually test to see if the dials spawn in correctly if we put this in our world. So let's take our BP lock. It's rather small now, but we'll be able to see it. We can hit play. It's just floating there by a locker. Actually, before we do, let's take a look at it when we're not playing. We can see that it's, since we're not playing, since we're not in runtime, no dials have spawned. But when we hit play, and this begin play here is fired, we walk up to it, we now see we have these oh, well, crouching's too short and standing's too tall. We have these 4 dials in there, and they're all facing 0. I'm gonna bring that up a bit. No idea how, yeah, I brought it up way too high. That's all right. You guys can see what's happening. So now let's add some variables to our dials. So we can go to our lock dial, because we need the ability to actually turn these. And we need the ability to know which number is facing towards us, so we can tell if we've got the correct code. So a few things we need. The first is an index. This will let it know whether it's lock number 0, 1, 2, or 3. So this is an integer. This allows us to make sure that we put our code in the correct order, because we don't want them to be able to put the numbers in any order. It needs to be the correct order. And the index should be instance editable and exposed on spawn. And before we continue, we can actually just, here if we have our spawn actor BP lock dial, if we right click and refresh it, since we set our index to be exposed on spawn, it shows up here now, and we can just plug in our index to our index right there. So now one of these will be assigned to 0, 1, 2, and 3, which is exactly what we need. We used a very similar technique when we made our inventory slots, because each one of our inventory slots also has an index. So the second variable we need is also an integer, and it'll be called number. This is the number that's 0 through 9 that's correct for that specific dial, since each one will have one correct number. So how do we let this know what number it is currently displaying? And this will be based off our rotation. So we notice we have our 0 facing out right now, and our rotation on our x-axis is at 0 degrees. This dial has 10 sides because it's 0 through 9. And if we were to rotate it a complete 360 degrees, it would look like absolutely nothing's changed because it's rotated once all the way around. So every number is based off 360 divided by 10, which is 36. And you can see it's rotated, and now 1 is facing out. So the numbers are solely based off of which number is the number that's divisible by 36. So we can also have 72, and that gives us 2. And we can keep going. I'm not going to save you the embarrassment of me trying to figure out how to add 36 to each of all of these, and we'll just set it back to 0. So to put everything I just said into one sentence, we just divide our x rotation by 36, and that gives us our number. So we can create a custom event, and we can just call it find number, and we'll just get the dial mesh, and we need to get its rotation, get relative rotation. We only need it on the x-axis, so we can split this, and we can just get the x divided by 36, and this will, and then we can set our number. So I actually got, I'm sorry, I think I mislabeled what this variable is used for. This number variable is actually the number it's displaying, not the number it needs to be. I believe I said that, so my apologies. This number variable is the number it's displaying. So right now, this variable would be 0. If we rotate it 36 degrees, it would be 1. Now, one clear problem we have with this is our number will keep going up forever as we rotate above 360. So if we were to rotate it to the number 360, instead of going back to 0, our number would become 10. So we don't want that. It's an easy fix. So, and we do this by in our event setting our dial back to 0 once it reaches 360. And since those look the exact same to the naked eye, we don't see it resetting its rotation. but we're going to do that in a separate part of code, so we'll save it for later. In begin play, we just want to call find number, so we can set our number variable. So just call find number, and we need a new variable. I'm going to call this dial rotation, and this is going to be the actual rotation of the dial, not that number divided by 36. So we'll have to make it a float. And we also need a variable called can rotate, and this is a boolean. We're making this because we don't want to be able to rotate our dial while it's in the middle of rotating, since we're going to create a timeline to make it actually rotate. We don't want to be able to rotate it again while it's in the middle of that timeline, because it's going to mess up what number it displays and what number it's supposed to be, etc. So let's create a custom event for actually rotating the dial, and we'll just call it rotate dial. Oops. And before we get started, let's make sure our can rotate boolean is set to true by default, because we want to be able to rotate it. And before we rotate the dial, we want to do exactly what I was just saying and check that we actually are allowed to. So if it's true, before we start actually rotating it, we want to set can rotate to false so that we can't. And then we want to create a timeline to actually then rotate it. So search for timeline, and we will call this rotate dial TL for timeline. And we want this to play from start. So we can open it up. We can add a float track, and we're going to call this alpha, as always. And we can change the length to however long we want it to take to rotate the dial. I'm going to do half a second, so 0.5. And I'm going to add 2 keys, like always, and just make a graph going from 0 to 1. So time 0, value 0, and time 0.5 and value 1. These 2 icons to fit it to the screen. Select both, and I'm going to change this to auto for a smoother rotation. So back in the event graph, we just have to get the mesh, set the rotation, so set relative rotation, put that into the update. We only need the X, so we can split this. And we just want to take the rotation we have and add 36 to it. So we'll grab our dial rotation, which keeps track of the rotation, or which will keep track of the rotation our mesh is at. We haven't set that yet, but we will. And we just want to add this 36. But since this alpha only goes from 0 to 1, we need to do this with a lerp. This goes into the alpha. And A is 0 and B is 36. So as the timeline goes on, it adds 1 and then 2 and then 3, not on top of each other, but it in the end it'll add only 36. And plug that into the new rotation for X. Now once it's finished, this is where we figure out if the dial rotation is 360, we want to reset that back to 0 so it doesn't keep adding up and up and up. So first we want to just set the dial rotation, and before anything we're just going to set it to this number that our rotation is at, and then we'll check if it's above 360, and if it is we'll update it to go back to 0, but if not it'll just be set. So we can get a branch right here, and we'll just grab our dial rotation, ask if it's greater than or equal to 360. And if that's true, we want to set our dial rotation back to 0. Now remember, this dial rotation doesn't directly control the rotation of the lock dial mesh, so we will also have to set the relative rotation on the X back to 0. And since these are 0 automatically, we can just leave this to look like that. Now, so once our dial rotates and then finishes and then figures out if it should be reset to 0, we want to find our new number, because our number is what we'll be checking to see if it's equal to the correct number. So after it finishes rotating, we will find the number. Now we also want to find the number if we aren't resetting the dial rotation. So off the false from this branch, we also want to find number. And I will create reroute nodes. After all of this is done, we want to be able to rotate again, because remember we set our can rotate to false as this all happens. And once it's figured out its number and finished rotating, we can now rotate it again. So we will set that to true. Now in find number, we want to replace the lock dial mesh relative rotation with our dial rotation, since this is the one being directly controlled by our rotate dial. So let's test this out if this works, because we added a lot of code, and I hope you're able to keep up. But before we continue, let's do some debugging to make sure everything works. So in find number, once we find the number, let's just print the string of what the number is to make sure we are going 0 through 9. And then in begin play, let's just rotate the dial every second so we don't have to personally interact with it. So we can just do that by setting a timer by function name. Our function name is rotate dial. Rotate dial. Time is 1 second. Looping is true. And to make sure we get there in time, we can just set the initial start delay to like 2 seconds. So it'll wait 2 seconds before it starts. All right, so let's test this out. So when we hit play, it should wait 2 seconds, and then the numbers that will appear, or the dials that will appear in our lock, will start rotating to the next numbers every 1 second, and our number should appear in the top left, and it should match what we're seeing. So 1, 2, there we go, 2, 3, 4, 5, and when it loops, it should come back to 0 in the upper left. 9, 0. Perfect. Look at that. So we're getting all 4 rotating, and it also knows what each dial's number is. But it looks kind of weird that all of them are starting at 0, right? And even in your game, to give that little extra challenge, you might want every number to start at just a random number. So we can add that in as well. So I'm just going to disconnect this set timer for now, but I might want to reuse it, so I'm just going to put it up there. And you definitely don't have to make them all start at random numbers if you want. You can leave them all at 0 if it's something you desire. But for us, we're going to make a function, and we're going to call it set random number. And we just have to get, or I think it's just called random int, random integer in range is what we want. And we wanted a number between 0 and 9. Both of these are inclusive. And then we could just multiply that number by a float. That will be 36. And this is because we need to set the correct rotation for our lock dial mesh. So whatever it chooses, we need to multiply it by 36. And we can promote this to a local variable, and we will just call it local rotation. And let's get our dial mesh, set relative rotation, and we'll split this because we only want it for the X. The X will be our local rotation. We also want to set our dial rotation variable to local rotation as well, because we want to keep both of those updated and on the same page. And the only reason we made this a local variable instead of just plugging this into both is because every time this would create separate numbers for both of these. So if we were to just put these in here, when it called set relative rotation, then it would call these two and we get a number. And then when we set dial rotation, it would call these again and we would get a different number. and that is why we use the local variable. After we set these, we want to call our find number event so that it also sets our number variable to the correct number. And in our begin play, after find number, actually instead of find number, since we have a find number in there, we can just call set random number. And that'll set our number variables as well, so we don't need find number there. So now if we hit play and we go over to our lock, look at that, it says 5698. I'm going to bring this down just slightly again. Just want it in eye level. And then we should get something different this time. 4357. Perfect. You also might have noticed, I should have pointed this out earlier, but the numbers that get printed on the top left will also match, but you have to read them from bottom to top, since the first one will appear on the bottom, second bottom, if that makes sense. So if we look at the top left, it's 0112, and then here 0112. Perfect. Now we need to set a code in our BP lock now. And while we're in here, let's go ahead and add a variable for is unlocked. And this will be a Boolean, but we don't want an array, so change this to a single variable. And so to create our code, we need to know our 4 numbers and which dial they're connected to, or in easier terms, what order they're in. So we're going to create a variable called lock combination. And this is going to be an array of integers, more specifically 4 integers. So make it integer, and then up here, change this to an array. And we want to add 4 elements, so 1, 2, 3, 4. So this will be our code. We can make it something by default. Let's just say like 9, 5, 1, 6, or something like that. And let's make this integer instance editable so we can make multiple locks and multiple codes. So if we click on it now and we go down here, this lock combination is now available, and we can change it to whatever we want. So we can make a second lock and make this one 0001 or whatever we want our lock to be. All right, back into BP lock. So let's create a function, and this will be called check code, and this will just check to see if our code is correct. And we'll do this with a for each loop with break. Now this for each loop will only break if it finds an incorrect number, which it'll do every time unless we have the correct code. So the array is this dial's array. And in the array element, we can get the number variable. So these dials, remember, is an array of BP lock dial, and we're grabbing our number variable from BP lock dial in each array element. So we just want to make sure this number is equal to the correct number in our lock combination. So we have our lock combination, but this has 4 different numbers in it, and we want to make sure the number is equal to the correct one. And we do that with our index. So if we get a get a copy, and this is the index of our array. So we have 4 array elements, so there's index 0, 1, 2, and 3. And we can get the index by plugging this into the array index. So now, if we ask if these two are equal, it's asking if the first dial is equal to the first number, second dial is equal to the second number, third dial to the third, etc. So let's create a branch right here. And if this is true, we need to set a local variable for local success. This will be a Boolean and not an array. If the number is correct, we want to set local success to true, which doesn't mean this function is over, because it can easily be reset back to false if one of them is wrong, which we can just add now. So let's set local success to false. And if it's false, we want to break the loop, because, here, one sec, let me create this reroute node first, because it's false, and then we continue and say the next one's right, and it would set local success to true, and then it would end, and it would think the entire code is right, because we have our entire code collected in this boolean here. So we need to break it to stop checking, because it's already wrong. So once this is completed, we just need a return node with an output called success with a question mark, and our local success will just be plugged into there. So let's create a quick way to just change each dial for debugging purposes. And we can just use some number keys. So in the event graph, and we can just create input, let's just use HJK now. So H and key, sometimes that narrows it down. Input J, input K, key. Sometimes you have to find it, sometimes you don't. Input L, key. Okay. And we'll just use these to turn each dial to debug. So we can just get the dials, and we'll need to get them at their specific indexes. So we get a copy, and let's just copy that 4 times, plug it into all of these, and we can just choose what index we want to reference. So 0, 1, 2, and 3. And when we press each specific number, we can just call rotate dial, which is our event from that specific dial. After we rotate the dial, we want to check the code. So let's just type in check code. And actually, before we check the code, we need to call a retriggerable delay of 1 second. Oops. Or I believe it is half a second, because we don't want to check the code until the dial completes rotating, because it's when it completes rotating is when the number is set. So we don't want to check the code before it sets its number. So we will have a retriggerable delay of half a second, and then we will check our code. And to be safe, we could even make it something like 0.6 seconds. But none of these inputs will work unless we enable input. So before we do any of this, we can just enable input from our player character. So we can cast to HG player controller. I'm sorry, controller, not character. Convert to pure. The object is get player controller. And we're actually going to need this as a variable later. So we can just create it as a variable now. So promote to variable, player controller. And after we do that, but before the for loop, we can just enable input. I'm going to pull it kind of like up here so we remember to remove it later on. The player controller is not the target, but it is the player controller, and the target is self, because we want this actor to be able to take input. So now pressing these buttons will actually register. And very lastly, let's print a string to see if it was successful. So this should only print true if we get our code correct. It'll print false every other time we turn a dial. So let's test it out. So let's click on this, and just to check our lock combination, it's 9516. So let's hit play. And let's go check this one out right here. Actually, real quick, I'm going to delete this because we have print strings in the upper left, and I don't want them all duplicated. So check this out. So 9516, I believe. So I'll press H. I'm gonna keep pressing it. If I spam it, you'll see it won't let me continue to rotate it until it's finished rotating the last one. So pressing it as fast as I can, it still goes at the same rate. We're at 9. Let's get to 5, 1, and 6. Okay, I'm at 5 right now. You see it had been saying false in the upper left the whole time. And when I press it once more, it should say true. 6. True. So now our lock is unlocked because we've given it the correct code. I know this episode's been going on fairly long, but a fun little thing we can add before we wrap up this episode is just plugging in that animation at the end to let us know that we have unlocked our lock. We can now get our hands on the good old goodies on the other side of the door, or inside the chest, or whatever you want to put your lock on. So back in BP lock, if we go into our check code, not our check code, our event graph, after we check the code, instead of printing a string, if it was, if it was successful, we can just play animation for our lock, so for our skeleton mesh right here. And the animation to play is our lock open. Compile and save. And let's test this out now. So hitting play, 9516 is the code, or is it 9156? Let me double check that. 9516. Okay, that was right the first time. Alright, so I'm hitting HJKNL to change them. 9, 5, 1, and 6, and then once I reach 6, after I hit it again, it should play the unlock animation. There we go. We have now unlocked our lock. Alright, I know it was a bit of a long episode and there was a lot of programming put into it, but I did my best to explain each and everything that we were going through, and I hope you managed to stay with me the whole time, and I also hope this inspires you for new puzzle ideas and different ways you could make just this lock in general, since there was a lot of different ways to do locks. We're not quite done with it yet. The next episode we're going to be creating a more intuitive way to actually change the lock numbers, because you don't want just players hitting 4 random keys on your keyboard that you can also do at any length. I can still change them from here if I want, so we don't want that. But since this episode is getting long, we are saving that for the next one. So I'll see you there. So we obviously don't want to open our locks by pressing obscure buttons on our keyboard. There's a couple different ways to set this up in terms of how we want to actually change each dial. One, we can set it up with widgets. Others, we can click the actual dials themselves. We're going to do it with widgets. So what we want to do is come into the BP lock, and we want to add a camera to it. So when we go into the lock view, we can have a set view on the lock exactly how we want it. So what we're going to do is add a camera, and we can just position this how we want it, bring it back a bit. I'm going to change the field of view from 90 to 45 so we get something a little tighter. And I'm just going to put this at 0, maybe 15, might be a little too far. We want a real nice close-up on it, and maybe something like -5 because the pivot point here is at the top. Next, we also need to be able to interact with the lock, so just so you don't have to have the trouble of trying to click on this tiny little lock here, we can add a box collision to it. We don't want a child of the camera. I'm going to center it on the lock, however. And for each block in the world, we might want to set these boxes to different sizes so we can cover up entire doors or chests, etc. So we're going to need variables to decide the size of these boxes. So we're going to create variables for those. And one will be called box position. That's going to be we do want it editable, and we want it as a vector. And then we want to make another one called box extent. This is also a vector, and it will be editable. I'm going to make the box extent default value to 32 on all axes. And in the construction script, we're going to get the box, set the extent to our variable. Now if we go into our scene, we can see we have this box here, and if we go to our details panel, we have this extent, and we can just drag these numbers here and it will update accordingly. We can do the same with the location, so we can just get the box and set relative location. And we'll get box position. Alright, so now that we have this set up, we can go ahead and use the box that we imported last episode. In meshes here, we have this box and box top. It's just a quick mesh to put the lock onto something. So I'll put it here in the light. I'm just gonna drag that out and drag this out as well, excuse me. And just position it. I'm gonna turn this down a bit. Okay, something like that's good, and we'll make sure this lines up. In most cases, you'd have this as an actor anyway, so be able to position it in the actor menu. Alright, that looks like what we want. Alright, perfect. Now we can put the lock onto our box here. If I remember correctly, the lock does not fit perfectly on this box thing, but I did make these fairly quick just as something to work with. Yes, it's definitely way too thick to be able to actually fit, but I'm just going to ignore that. I'm going to turn off snapping for a second so I can get it right on there. Cool. Now we have a lock on our chest. Now I want us to, when we try to interact with the chest, we go immediately into lock view, and that's what this box collision is for. So let's position this, not that way, we want it on the Z axis, not the Z, the Y. Third time's the charm. And we'll just kind of get that right in the center there. Same with the Z as well. And then the extent. Okay, something like that is good. So now whenever we try to interact with the box, it'll automatically interact with the lock because the box is not openable, I should say. So what we need to do is add our interaction interface to our BP lock right here. So we can go into class settings, implemented interface, we can add in BPI interaction. And we will create the interact event. Where are we? Is it the, okay. Our begin play, and under interfaces we have our interact, and we can right click and implement function. So when we interact with it, I want to be able to look through this camera so we can start messing with the dials. So what we're going to do is get the player controller, set view target with blend, and the new view target is going to be this camera. So we get the camera, and then we have to get owner, and then plug that in. You can also just use self, like this, and it'll automatically go to this camera, but I just like to select the camera. It'll give you the same result. Let's make the blend time 1 second, so it takes 1 second to go from our camera to this one, and that looks good. So we can test it out. So once we interact with our lock, which will hit this box, so if we hit this box at all, we will set the new view target to the camera. So let's hit play, and let's interact. It is not working. Let's figure out why. Oh, I realized our issue. In our box collision here, it is not interacting with our line trace from our character, which I just opened here off camera. So when we call the line trace, it does it through our visibility trace channel, And our box, if we go down to our collision, it chooses to overlap the visibility trace channel. So we need to change our collision preset to custom, and then we need to block the trace channel for visibility. So it will register that our interact hits it, and it should work now. So I'll press E on it, and there we go. And wow, flat textures look pretty bad this far up close, but everything works as it needs to. So we want to disable our character movement while we're in our lock state. So we can go to BP lock, and after we set the view target with blend, we can get our player character, and we are going to disable movement from our character movement. We also don't want to be able to look around, so we will get our player controller, and we are going to set ignore look input, and we will get our player controller ref, and we will set can open inventory to false. So it cannot open the inventory while we're checking the logs. Now once we're inside our lock view, we want to enable input so that if we hit the escape key, we can exit out of the lock view. So what we're going to do first is we're going to delay, and the amount of time we're going to delay is the same amount of time the blend time will take. So we only enable input once we're fully in. So I'm just do one. You can definitely set this to a variable if you want to. And then we will just enable input. And then we can just create the inputs for this. So I'll do input escape. And we're going to have a custom event for exiting the lock view. So let's create that before we do this. So custom event, exit lock view. We can just copy and paste this. So we want to set our view target back to our player. So we can delete this camera. And the view target will be our player character. We also want to disable input right as we do this. With our player controller being our player controller. We want to re-enable look input, so we will call reset look input, reset ignore look input. And we also want to be able to open the inventory, so we can get player controller, can open inventory. We want to set it, not get it, can open inventory to true. And we want to set our movement mode to walking. And if you remember, I've explained this before. This is the equivalent of re-enabling movement from this disable movement node right here. But we have to choose the mode, and that is walking. And now we'll be able to get in and out. So if escape is pressed, we will call exit lock view. Now, of course, if I were to hit escape in our game right now, it would just close the preview. So I'm also going to set this to the backspace key, just because escape won't work. And I will also set it to our action key, which is our E key. So if you were to press E again, you can get out of it. So now we can actually test going in. So I'm going to press E, and we're in. And I'm going to press the buttons to walk around, and I'm going to try to look around, also open my inventory, which doesn't work. And if I were to press E again, or backspace, we go back to our character, and we are in the same spot. Cool. So that works just as intended. So now we have to make the widgets for changing the dials. So we need to import the texture. It's just these arrows I made. So I have them right here in my resources folder, which will be in downloadable. I'm just gonna hit open. I will open this. Compression settings will be user interface, texture group, UI, and filter. We will keep this at default. Save. So let's close this, and we need to make a new widget. So user interface widget blueprint. I'm going to call this W arrow and open it up. We can replace the canvas panel with a size box. Right, we can't do it like that. We have to delete it and search. This will be desired on screen, so we know how big we're making it, and we will set it to 256 by 256. And we need to add a button, and this will be the arrow. So when we click on this arrow, it'll change the value of the dial. Let's make the image size 256 by 256. And it looks really weird right now, and that's because we are drawing it as a box when we need to be drawing it as an image, and that fixes it. Drawing it as a box, the sides and the middle stretch based off a margin with it, whereas an image won't do any stretching. All right, let's change the hovered and pressed. So I'm just going to copy the normal and paste it into hovered and pressed. And then hovered, we can just make it some kind of color, like blue maybe. And pressed, we can make it like a dark gray. All right, and we can compile and save that. So now in our lock dial, if we go to blueprints, actors, lock dial, we need to add these widgets. So let's add a widget component, and we will call this up arrow. And over here in widget class, we need to change it to arrow. The scale is going to be 0.001 on all axes. So it's real small. And we need to rotate it 90 degrees on the Z. I'm going to change this to 1, so it's just a little bit above it, and 1 on the Y, so it's a little bit forward, just so it won't be clipped into the lock itself. And this one obviously needs to be rotated on the X-axis 180 degrees, so it looks like a up arrow. And then we can just duplicate this, and we'll call it down arrow. And on the Z, it'll be -1, and the rotation on the X will be 0. And then we can compile and save, and we can actually just go in here and see how the arrows look. If we hit E, we now have our arrows in front of our dials. So let's go back to the widget. So we can actually, oops, that is the wrong widget. So we can actually add some functionality. So let's go into the graph. And let's add a Boolean. We're going to call it add rotation. And it'll default to true. So basically, if this is true, it will add 1, and if it's false, it'll subtract 1. Not like should we add or should we do nothing. So if we press our button, so on pressed, we just have to ask if we are adding rotation or if we're subtracting it. So if we're adding it, then we need to rotate the dial in BP lock dial, but our arrow widget doesn't know of BP lock dial yet, so we need to add that. So let's add the variable lock dial ref for reference, and it'll be of type BP lock dial object reference. And now we actually need to set it. So let's make a function called initialize, and it will have an input of our lock dial ref. So we can just set it like this and then drag this onto initialize, which will automatically create an input for us. And let's do the same with the add rotation. All right. So now we'll know for both. So now that we have a reference, we can drag off our lock dial reference, and then we can call the function, I'm blanking on what it's called, rotate dial, of course. Rotate dial. So we need a new event to rotate the dial backwards in case we want to subtract rotation. So if we go into BP lock dial, and we can just create a new one right now. So custom event rotate dial backwards. And we just need to ask the same thing if we can rotate. So I'm going to copy and paste that. And if it's true, we want to set can rotate to false, and then we want to call reverse from end on this timeline that we already created for rotating our dial, but this time we will play it in reverse. But no matter whether it plays or reverses, we are still looping from 0 to 36, and if we were going backwards, we want to rotate it negative 36 degrees so that it goes backwards. So I'm going to move this out of the way, and we are going to create another loop. So I'm just going to copy and paste that, plug the alpha into alpha as well, but change the B to negative 36. Now we just have to decide which one of these two should we use, and we will decide that based off the direction that our timeline is going. If it's going forward, we want to rotate it 36 degrees forward. If it's going backwards, we want to rotate it negative 36 degrees. So whatever we're adding to the dial rotation, you'll get a select node. The direction will be the index, and if it's going forward and backwards. Now we need to add a little bit more logic, like we did right here, to make sure it always stays between 0 and 360. So off this false here, all it does is just skip to find number. But now we need to add another if statement, because we are going backwards this time, so we don't only have to check if it's greater than 360, but we have to check if it's less than 0. And we'll plug that in. And if it isn't, we can just continue to this find number. We don't have to do anything. But if it is, we need to set our dial rotation to a new number that stays inside the values of 0 to 360. And we'll do this with a map range clamped. The value is the dial rotation. And then if it's anywhere between the range 0 and negative 360, we just have to convert that to a range of 360 to 0. We will then set the relative rotation of the lock dial mesh at this number. So it resets to a number between 0 and 360. After that, we can go back into our find number function. All right, so now that we have the rotate dial backwards set up, we can go back into W arrow, and if we don't want to add rotation, as in we want to subtract rotation, we can now call rotate dial backwards. Set that to false. So let's go back to our lock itself, and let's get rid of these HJ, K, and L since we don't want to use them anymore, but we leave everything else. And we also want to get rid of this enable input because now that we're not using it for debugging, we no longer want the lock to have input. Great. So we need a new custom event called check every turn. And essentially what we're doing with this is checking every single time we change a number if the code is correct. Kind of what we were doing here, but we need to make it into an event now. And we will need a variable in our lock dial of the BP lock. So we will create that, call it BP lock ref. Let's type BP lock. Oops, BP lock. Okay, had a little trouble typing that. And we want it to be editable and exposed on spawn. So that when we go back into our lock, if you remember, we spawn in our lock dials here in a for loop. So we can just right click the spawn actor and refresh it. We now have our BP lock ref show up right here. It's a little bit more efficient than setting it in an initialize function. So we can just get a self variable and plug that in. And the reason we've created this variable is because we want to call this check every turn event every time we turn the dial. So at the very end here, after it's all finished, and after we find the correct number, we just want to get our BP lock ref and call the check every turn. So every time we turn a dial, it'll check to see if the full code is correct. There is a warning here, and that's just because we have not compiled. Now it has registered that it exists, and we are good to go. Right, one more thing. It's important now, just because it's possible for our rotation to go into the negatives as well. Since we can rotate it backwards, we need to get an absolute of this right here. So it always converts it to a positive number. If we didn't do this, then we could end up inputting some code like 951 -6 rather than 6. By absoluting this, it'll always be converted to positive, so 951 6. So let's actually fix up this check every turn. We can just take this logic right here, and I'm just going to bring these down. Just a bit of organization real quick. I keep messing it up. And we no longer need to call the rotate dials because that will happen with our widgets when we click our widgets. We just want to check our code, and we don't have to worry about this delay either. So let's bring this over here. And I'm just remembering now that we don't actually need these right here, but I'm going to leave them for a debugging thing that we might do later. So you can delete these if you want, but you might have to put them back in if you want to create a debug. But this is all we have to do. Check every turn. We just have to check the code, and if it's true, we play the animation. But we still lastly need the ability to press the arrows, because when we go into our view right here, our mouse is gone and we cannot click anything. So go to BP lock, and when we interact and go actually into the lock view, and just show the mouse cursor when we are in lock view. So check that, and then I'm going to copy it. So when we exit the lock view at the end here, we are going to hide the mouse cursor once again. So uncheck that. Target will be our player controller. We can put it here, or you can just get player controller. Do it like that. Either way, it should work. Now we just need to be able to click on the 3D widgets, which works just a little differently than clicking on it when it's actually in your UI. We need to add something called widget interaction to our BP lock here. We definitely could create a new trace channel for this if we wanted, but visibility will be fine for us for now. And you can change the distance. You can imagine this as a line trace, how we were doing with the interaction, except the line trace is coming out of the point where you click. So this is the distance, 500 will be fine. And the interaction source, we want it to be mouse. And then we just have to set our left mouse button. So we will call input left mouse button. And on pressed, we get our widget interaction, and we call press pointer key to the left mouse button. And unreleased, we will do the same for release pointer key with left mouse button. And now we can test it out. We should be able to interact with 3D widgets by left clicking through this BP lock actor. So let's hit play. And I know we went through a lot since the last time we tested it. So if you remember, there's a box that we could set anywhere we want, and we set it to completely surround this chest. So if we want to interact with the chest at all, even if I hit over here, we will go into our lock view, and you can already see my mouse is interacting with these 3D widgets that are just placed in the world, creating a trace. So when I'm hovering over them, they turn blue. And then when I press the up button, absolutely nothing happens. This was unintentional. Let me figure out where we went wrong really quick, and I'll be right back. So as soon as I exited out, we got our runtime error access none trying to read property lock dial reference in our W error. So let's go into the function by clicking it here. And it doesn't know what we're talking about when we have this lock dial reference despite this initialize function. And I know exactly why this is. We never called the initialize function anywhere. So the function exists, but it's never called. So what we need to do is go into our lock dial where we have our two arrow widgets right here. And in the event graph, we have to go to the begin play. And before we set our random number, we're going to call those initialize functions. We have to do it for both. So let's get the up arrow. And sadly, we can't call functions just from this variable here. We have to get user widget object. And through this, we cast to our correct class. So cast to W arrow, or I should say cast to our widget. And we can convert that to a pure cast if we want. And then as W arrow, we can call the function initialize. So our lock dial ref, that'll be our self. So we can just get our self reference to self. And for our up arrow, we do want to add rotation. Now we can copy and paste all of this, and we just need to set it for the down arrow as well. So I'm dragging this over the up arrow, and it replaces it with down arrow. But we don't want to add rotation here. We want to subtract rotation. So I'm just going to uncheck this. And now it should be working. So let's hit play. Let's say E on our box. We're here. My mouse is still interacting with the widgets. And when I actually click on this, it should know that this is the lock dial we're talking about, and we want to call add rotation. So it should add a rotation. Perfect. If I spam click, it still waits for it to get all the way to the all the way rotated, so it doesn't get buggy at all. And as you can see in the top left where the debugging is happening, it's correctly looping, and it's not going too far. And if we hit the down is not working. We have made another mistake. And when mistakes like this happen, I like to remind everyone that I like to keep the mistakes in the video, because I want you to see that it's very easy to make mistakes, and it's also good to learn how to find them. So we know that when we click the down arrow, it seems to jump to the one below it and then rotate up to the one above it. So something about this math is wrong. So let's go into our lock, or our lock dial, I should say. And we have a rotate dial backwards. All this should be correct. And we reverse our timeline. So it does reverse the rotation. That's actually working correctly. And I already see our issue. It's because we go from 0 to -36 when we need to go from -36 to 0. Let's see if that fixes our issue. Let's hit E. Let's go up. Up still works, and down works. And if you look in the lower left, or upper left, I'm sorry, our numbers are updating accordingly. Perfect. So just a small little fix there, something very easy to make the mistake. Happens to everybody. So let's make sure our check every turn is working. So right now, we already know it's checking every single time. I changed this if the code is correct, and every time it said no so far. But let's put it to the correct code, and let's see if that registers and opens our lock. So let's change this to, I'm still forgetting our code, but I'm pretty sure it's 9516. And it has opened, and we are still in here, but we can press E to get out. So I think what we want is to polish it up a bit. So first thing is I don't want those widgets showing when we are not out of here, you know, because it just kind of looks like some weird white dots on there. I don't like the look of that. So I only want the widgets to pop up when we're in the lock view. I also want us to exit the lock view if we have solved the puzzle. But all the mechanics so far work exactly as intended. So in our lock dial, let's take these arrows and let's go to visibility. And we're just going to turn visibility to false. So if you see, turns invisible and turns invisible. Great. So they won't be seen by default. In the lock, we want to set them to visible when we go into our lock view. So event interact, we do all of this, and after we show the mouse cursor, we want to show all of the widgets. So we can get our dials, and we need a for loop, or for each loop. And we can just get the two dials, so we'll do up arrow, not dials, the two widgets. So get up arrow and get down arrow. And we will just set the visibility to true for both of them. Okay, perfect. And then we want to turn these back off once we exit the view. So I'm going to copy these, and then here in our exit lock view, right here, at the end, we're just going to do the same thing, call a for loop, turn these off. So now if we hit play, and we get as close as we can see there's no widgets, and we hit E, they've turned on once we're here. If we hit E again to leave, they are gone. All right, that already looks a lot better. Lastly, I think I want it so if we solve our code, that we automatically exit the lock view. So let's go to BP lock, and here in check every turn, on off success of check code after we play animation, we're just going to do a delay. I'm going to say just about 2 seconds will be fine, and then we can just call exit lock view. What you could also do is delay, say, another second or so, and then destroy the lock actor. So we can do destroy actor. You will also have to, since the dials are separate actors, you have to destroy those as well. So if you want to destroy them, you'll also have to go for each loop with the dials, and you would just call destroy actor like that. And this will destroy all the dials as well. So it's a compile and save, play, and what we're gonna do is test this out one last time. Let's get it to the correct code, 9, 5, 1, and 6. Waits 2 seconds, and then we leave, waits 1 second, and the lock is destroyed. And then we could interact with the chest per se if we had set anything up like that. So I know this was a quite a long episode, but now we have a perfectly functional lock that's should be customizable as long as you have the model, 3D model to support it. So thank you for watching, and I'll see you in the next one. Many horror games have notes or letters lying around the world to fill yourself in on the past of what's happening in this story. Before we get started on this episode, I would like to say it is important to note to not make your entire backstory discoverable through notes or just reading in general. Notes are meant to give the player a little extra as a reward for taking the time to read them. And definitely don't put an explanation in a note that would be game-breaking if they never found said explanation. Many indie horror games make the mistake of switching between running from something and reading explanations for why you're running from something way too often. Now, you'll want to choose at the beginning if you want the notes to be inventory items. In most games, I've noticed people don't want this unless it's a separate inventory just for notes. If you made it a regular inventory item, they would always be the item players would drop first to make more room, or they might be too scared to drop notes in case there's something they need to come back to, and it would flood their entire inventory. And it would be much less annoying for notes not to take up any inventory space at all. So we have to make a new folder. Let's do this in Blueprints, and then in Actors, and I will just call it Notes. And we need to create a master class. So right click, Blueprint class of type Actor, and we will call it BP Note Master. And we need to import a mesh for the piece of paper the note will be on. Once again, I've created something very small in Blender that you should replace. So I'm going to go into Props, Meshes, and hit Import. And I will navigate to where I keep my paper.fbx and open it. Auto-generate collision is fine. It's not a skeletal mesh, and we don't need to create a material. Or actually, we can go ahead and create a new material. We'll just change it. So let's hit Import. And we just have this very simple piece of paper right here. It's just the very thin box that I created. And it didn't seem to make a new material anyway, so we'll just go into Materials and create a new material for this. We'll just call it M Paper, if I can press the correct buttons. And I'm just going to make it as close as I can to a paper color. Let's see how well I can do this. Something like that should be fine. And I'll just use that. Alright, perfect. Alright, so let's go back into our BP Note Master. And I'm just going to close all this lock stuff that we did in the last episode, and I'll go ahead and close the paper meshes and materials as well. And we are going to add a static mesh. This will be called paper, or we could call it paper mesh, either works. And we will set it to the paper. We can also set the collision presets to overlap all if you wish. It won't be physics based, but in case it's anywhere where you don't want your player to be affected by it, then that's an option. So now we need to decide what will be said on the paper. Of course, an option is if you want to completely hard code everything in and just create a bunch of different note models with different texts saying exactly what you want them to say, but that's far less efficient than using the same piece of paper with a text renderer, which is what we are going to do. So we're going to add a component, text render, and we'll just call this note text. And let's take a look at this. This will create a 3D texturist that we'll place on top of the paper to make it look like it was written on. So let's scroll up. We are going to change the alignment to left and top. So you see the pivot point here is in the upper left side of it, so we can put that in the upper left side of our paper. World size, we'll make it a lot smaller, maybe something like 2. Yeah, that looks right. Let's make the color black. The text render color, I'm gonna make that black. And we need to rotate it accordingly, so z-axis 90 and y-axis 90. Okay. Now if we were to put the z at 0, you'll see we get this jittering effect because this is on the exact same z-axis as the paper is. So we want it on the paper, but we want it just slightly above. But we don't want to see any space in between because this is not supposed to give the illusion of floating text. So we're going to give it a z-value of 0.001. That'll get rid of the jittering, and you probably won't ever be able to see the distance between the text and the paper. Let's also move it to the upper left, unless you want the text directly in the center. And I think -10 and 15 work. Well, that's the wrong way. I meant -15. There we go. Yeah, and that looks good to me. So let's change the font because we don't want to use Unreal's default Roboto font. It definitely doesn't look like handwritten text. And this will require some setting up since 3D text is different than UI text. You can easily import a handwriting type font or make one yourself if you know how to. Since we already have an episode on importing fonts, I'll just be using the font we already imported, but since this is supposed to look handwritten, unless it's supposed to look typed for your game, you will probably want to import another one, so you can go back to that video and reference it. So I'm going to go into Content and Fonts, and here we have our Calibri font. And I'm just going to take our font right here. If you remember, this is where we created all the different types into one font, and I'm going to duplicate it. And I'm going to call this Calibri font underscore distance field and open this up. The font cache type needs to be changed to offline, and we can hit yes. Now we can choose our font right here. I'm going to find Calibri, which is what we're using, and you can choose a font style. I'll go with italic and a size, and I'm going to go with 22. So this is our sample right here. And then we can hit OK. We also have to go into details and search for use distance field alpha, and we want to check this. Cool, this is looking how we want it. So we also need a material to handle this 3D text for us. So we're going to right click and create a new material, and we'll call it Calibri font. And that should be good enough. We can open it, and we need to change the blend mode to masked, and we also want this to be two-sided. For the base color, we're going to get vertex color, and we need to import our new font right here. So right click and search for font, and we'll get the font sample. And we will just find Calibri font distance field, which is the one we just created. And from this red channel, we will get a lerp, or linear interpolate. Put it into the alpha, and the lerp here will go from -90 to 90. We might need to refresh this. We can just save and apply, and there we go. -90 to 90. And this will go into the opacity mask. But we are getting this, it's just plain white when it's supposed to look like our 3D font here. And so what we need to do is just right click on our Calibri font distance field and hit re-import. Now our font looks like this, which is the way we want it to look. And our font here has gone completely invisible. So let me just try deleting this and then searching for it again, see if that fixes it. Put the alpha, red into alpha, not A. There we go. And now we have our 3D fonts. If we set this to a plane, it might be a bit easier to see. Perfect. So let's go back into our BP Note Master, and now we are able to select as a material which one we want to use. And we can search for Calibri font. And we're also going to have to change the font here from Roboto to our Calibri font distance field. And there we have it. We have our text in 3D. So if you want to do that with any other font, you'll just have to go through the exact same process of creating a font here, going through the steps of turning it offline, etc., and then creating a material in the same way I did. So we can add a placeholder text right here just to test something out. This note is very scary, and the monster is coming for you. And we can see, obviously, that this goes way off the page. So if we find the spot we want to break the line in between thee and monster, I'm thinking, we can add a BR in between some carrots, and then that creates a line break. Great, so now when we spawn these notes, we need to know what text we want each one to say. So we can go into the construction script, and we will get the note text, and we will search set text, and we will promote this value to a variable, and we'll call this note text, and then we can text like that. And we'll make this editable so we can change it. We can also see that the break will work in the variable as well. So we can type, it's too late, the monster has eaten your family. And if we go into the viewport, we can see it's updated, and I want to add the break before eaten. And there we go. We've created quite a morbid story here between these two examples. So this next part is we want to make these notes interactable. We want to spawn these into the world, and then we want to be able to interact with them so we can read them up close. So we're going to set this up very similar to how we set up our inventory items, just so it works in the same way, by adding a overlap sphere. So sphere collision, we'll call this overlap sphere. And we'll make the radius something like 500, something pretty big. And we're going to be adding a widget for notifying that you're close enough to pick it up. And I'll just go ahead and open up an inventory item so we can get refreshed on what I'm talking about. And let's just take the key, for example. And right, so we have this sphere, we have the prompt widget, and the static mesh. And if we want, we can actually just copy and paste it, I believe, from here, even if it's inherited. So let's go into Notemaster and let's paste it, and there we go. It's in there. And it should be at the correct scale, the correct Z value. Well, that's actually quite high. So let's bring it a little closer to the note. So maybe something like 20. Make sure the visibility is false by default, which it is. And we can also just copy the functions from the pickup actor for when to turn this visible and such. So let's go into the pickup actor, event graph. Let's get the master actor instead of one of the children, so that we actually have all these functions. And we can just copy these two overlaps for the sphere and the event tick, so we don't have to write all this out again. So Command C, or Control C I should say, and Notemaster event graph, Control V. Alright, so let's delete these two because it doesn't know we're talking about the overlap sphere here, and then we'll just create them for this. So on go ahead and begin overlap. Put this into other actor, and then same thing here on component end overlap. Put this into here. So now it knows we're talking about the correct sphere. We don't have a variable for our player ref in here, so we can just right click and create the variable for it. And we'll have to do the same for this update actor variable. There we go, now they're both variables. We should be good here as well. In the tick though, the static mesh we are referencing should be our paper now. So let's drag this over the static mesh to replace it with the paper. We can just go through and see if we have any more times we reference that static mesh. And it looks like we don't. if this widget here, if you didn't copy and paste it or named it to something else, you will have to replace this prompt widget variable with this. Since it's named the exact same thing, it automatically detected it, so we don't have to switch it out. But that is a warning, because you might come across with that error if you change the name right here, or if the name's different in the master. We also have this widget distance above mesh variable for how high this widget should be above our mesh, so we can create a variable from that as well. Let's go ahead and compile so that we can set it. I'm gonna set it to 25. And we still have another one. Here it is, pickup distance. So how close can we be to it before we can pick it up? So let's right click and create it as a variable. And I will make the pickup distance 150. Alright, so we can put this in the world right now to test to make sure that the widget works like all the other items do. So I'm going to just turn this camera speed back up because we were going way too slow at the moment. I'm going to bring this light in this corner, and we can put the note master in here. Now remember, if you spawn inside an overlap sphere, the overlap detection will not work, so just make sure you're not doing that. We can hit play. And then notes over there, if we enter the sphere, the widget should appear, which it does. And it's always rotating to look at us, which is nice. And if we go all the way up, or close enough, it turns into an E, knowing that we can now interact with it. Of course, us pressing E doesn't do anything, as we didn't set that up. But we can also, even without picking it up, get real close to it and just read the text like this. Of course, if it's pinned to a wall or sitting on a desk, you won't be able to stand inside of it and read like that. But for our sake, we were just making this float in the air. Of course, if you want, you can just, we can make it pinned to the wall right now. I do want to do that. Make sure the right side is facing outwards. And there we go. Now, upon interacting with this note, we want to use a similar examination setup as when we examine objects in our inventory, so that we can check the note for backsides, things hidden on the other side, if that makes sense. So if we examine one of these, we can rotate it around and look all around it. You, of course, don't need to do this at all. When you interact with it, it could be as simple as creating a UI with a picture of the note with the text displaying what it is, and that's all it is. It's just a widget. And for many games, that would actually be a very good and a very valid method of going about this. But since I feel like we've talked about UI enough where you'd be able to do that on your own, we're going to do something a little more complicated, just in case this is the type of thing you want to go with. So to examine this, we are going to change this to unlit so we can see things. And over here we have our examination component where we examine items in our inventory. And we want another one of these for the notes specifically. So let's duplicate this scene capture component. I'm going to duplicate the lights with it, so I'm holding down Shift. And then I will hold down Alt and drag all these out. And we're going to have to change these point lights to movable so that the red X's disappear. So we need a new render target for this, because we don't want to use the one that's checking at the inventory items over there. So if we go to Content and Blueprints, Render Targets, we can just duplicate this. We'll call this Note Render Target 2D. And we can open it up. We can't see anything with it right now. I'm going to make the size bigger since the notes are going to be bigger in the widget. It's a good idea to try to match this size to the size you'll be putting it in the widget. And we need an item to examine. So it'll be very similar to our examination item over there. So we're just going to duplicate it and change some of the code. So let's go into Actors, and then it's in Inventory. So we have BP examination. I'm just going to right click, copy reference, and then go into Notes, and hit Control V to paste it. And we will call this BP Note Examination. We can open it up, and the item mesh here, we can just change to paper, since it's always going to be this paper. And we also want the text here, and we're just going to copy it from our Notemaster so we don't have to mess with all these, this text, so we don't have to mess with all these settings again. So let's just copy, go into Note Examination, and hit paste. Let's make it a child-defined mesh. And now the reason we're making a second examination actor is because it'll be much easier to just update this text on the notes rather than adding and removing text in the correct position, whether it's a note or not. All right, so let's put this note into the world relative to this scene capture component. And let's make it a child of it. So I'm just going to drag it and scroll all the way down to scene capture 2D4, which is the one it is right now. And I'll just change the location to 000 and just drag it out a bit for now. And we'll figure out exactly where that should be later. In the scene capture component, we want to change the texture target, which we forgot to do, to the note render target. And let's change the primitive render mode to render scene primitives legacy. And we're doing this because in my experience, the other option doesn't render text as well as this does. So we're just saying, just don't render the sky sphere, which means we're gonna have to rotate this away from our building, so that is not seen either. So if you have a sky sphere in your scene, you want to go here to Hidden Actors, press the plus button, and then you just use the eyedropper to select the sky sphere. We don't have one in our scene, so we don't have to worry about it. So now we need to duplicate the material for the render target because we don't have one for our notes. So let's go into Content, Materials, M Examination, and we'll hit duplicate, and we'll call this M Note Examination. We can open that, and the texture sample is going to be our note examination, or our note render target 2D. That thin little line there is our piece of paper. We can actually just rotate this so it's a little easier to see, like that. There we go. So now we need a widget to display this material, which is the same way we did it with the other one. So we can duplicate W examination right here. I'll hit duplicate, and we'll call it W note examination, as we have for all the other things. And we'll bring it out of this inventory folder just into UMG. We can open up note examination, and let's just go ahead and delete the item name and item description because we don't need them. So delete and delete. Now we have our image, our background blur, and our drag detection. We'll leave all three of those so we don't have to recode them all. For the image, we can change the size to 124 by 124. Hence why I said change the size in the render target. And the image is going to be not M examination, but M note examination. So it's the note instead. So in the graph, we're gonna have some errors because we removed some text. And we can actually delete everything after this update widget custom event because this just updates, and the other one, the name and the description and the static mesh, and we just don't need any of it. So we're gonna delete that. If we compile again, we're no more errors. We can also delete the inventory reference because we don't use it either. It automatically puts it under components. So we can delete that. We'll hit yes. And it's being used on mouse move. So we will come back to this and fix it. So to reopen my event graph because it closed, just double click right here. What we do need is a reference to our note examination actor, which is this one right here, BP note examination. So we'll create that. We'll just call it BP note examination ref. and we'll just search for that, BP note examination, object reference. We also want to make it exposed on spawn. And in this update widget, we don't need an index, but we do need it to be a reference to the note master, which just reminding you, it's basically the pickup actor, so that we can get the text variable to add to the examination. So we'll change this index. We will call it note, or we'll call it note master actor. Actually, no master, because we'll have children of it, so just note actor. But we will make it of type BP note master. Now, before we continue in this update widget, we still have the errors, but don't worry about that. Let's go back into Note Master, and let's actually make something happen when you hit E when you get close enough, because right now it doesn't do anything. We do have enabling and disabling input active, so when you get close enough to it to hit E, it is registering that you hit something, but it doesn't do anything. So we will create input action, which is our E key. And when we press it, we just want to create the widget note examination. So pressed, we will create widget, and we will search for note examination. And now we have this BP note examination reference because we made it exposed on spawn. Now we don't have the variable to plug into that yet because this is asking for the note examination actor, which is the this one right here, not the master. So it is not self, it's the other one. And I'm just going to start closing these font things because they're getting in the way. Play yes to apply changes to the font. And this is the door key, we can get rid of that. Pick up actor master, we can get rid of that. Render target, we can get rid of that. So we have master, note examination, we can get rid of the material, we can get rid of the old widget, and we have this widget now. Okay, that makes it a lot more clearer, should be easier to follow now. So after we create the WNote examination widget, we want to call update widget, which is this one right here. And this one we can put self for the note actor because it's asking for this note actor, which holds the text variable. After we update the widget is when we can add it to the viewport. So add to viewport. Now let's get the variable to plug in this right here. So in the begin play, which is right here, we just have to get this note examination actor. Now there's only ever one in the world, which is the one this camera is facing. This is the only BP note examination that will exist. And because of that, we can find it by using a get all actors of class, searching for BP note examination, and then out of the out actors we can get a copy, and we will get the first index because there only is the first one, and then we will use that and promote it to a variable, and we'll call this BP note examination ref, and now we have our variable for that, which we can plug in to this right here. So now let's fix the error in our WNote examination, which is in our on mouse move because it takes a reference from the inventory, which we don't need. Because what we are adding rotation to is the note examination actor. So we can delete these, get our new BP note examination ref variable, and get the static mesh. Or what did we call it? It's called item mesh. Item mesh. And that's what we will be rotating. Since the text is a child of the item mesh, it'll rotate with it, so you don't have to worry about the paper rotating around the text. Alright, so let's go back to the event graph, and in update widget, all we have to essentially do is update what the text says on our note examination. because this note master will have a lot of children depending on how many notes you have, each one with different texts. And this note examination just updates the text, so you don't have to constantly replace which note is showing. You just replace the text. So we have this note actor reference, which is a reference to our note master right here. And we can just get the text variable from that. So we can get the note text, and we will set this text to the text in the BP note examination. So we'll get the BP note examination ref, and we'll get the text from here, which we call note text. So we'll get note text, which is the object, and then we will set the text inside of that. So set text, and this will be the value. Now in the close examination widget, so when we close this widget right here, instead of toggling the inventory, we just want to remove it from the parent because this has nothing to do with our inventory. So to test this out, we just have to make 2 notes to make sure it updates correctly. So let's go into content, blueprints, actors. I'm going to change this back to lit, notes, and we have our note master right here, and we create children of this, and we will just call this BP note. I'm just going to call it first note and second note. So I'll duplicate first note, call this second note, and I will delete the master from the world and replace it with the first note. That's not overlapping. Okay, great. And let's just open first note. Let's change the text. So this one can, oh, my camera speed is very slow. This one can say, hello, welcome to the mansion. Something like that. We are now in a mansion setting. Oh, I just realized we need to change it in the, I thought I was changing the variable text, but I was changing the text in here, but it's all controlled through this variable, so you need to type it in this variable. So, hello, welcome to the not haunted mansion. And we will want to add a line break before haunted. There we go. And then the second note will say, turns out the mansion is haunted. And I will add a break here as well. Okay, perfect. So now if we take these 2 notes, I already put the first one right there. If we take the second one right here. Okay, I'm gonna hit play, and I'll just go to the first note first. And if we hit E, it should create this widget for us, and it says, hello, welcome to the not haunted mansion. And that's great. If we hit backspace, it goes away. Now if we go to the second note, the widget should update, and it should say whatever's on this note, which is, turns out the mansion is haunted. So this examination widget is working correctly, which is great to see. Now we just got to polish it up a bit and add the ability to rotate the note. So let's go into content, game BP, and we're going to open the player controller. And we have this toggle inventory custom event, which does essentially what we want it to do in our widget here, minus the actual inventory opening. So let's just get these here and copy all this. And let's copy this set input game modes as well. So this is everything I have copied: the movement modes, look input, mouse cursor, and input modes. I'm going to Control C. I'm going to go into W note examination, which is this one right here. And let's just find a free spot and paste all that in. And bring this closer. And all this stuff on the bottom where we disable the movement and ignore the look input, we want to happen when we come into the widget here. So let's just take all this and drag it up to the event construct. And we'll get this bind event after. So I'm going to pull this up and I'm going to break those. And then after we cast to the player controller, we will do these things. And I'm just going to move these over here for now. So we cast to the player controller, we get the player character and disable the movement. Ignore look input, we'll need a player controller reference, so we'll plug that in. Same with show mouse cursor, we need to recall it, so set show mouse cursor. Just replace it with this one. Set that to true. And we also set input mode to game and UI. Put this into player controller. Widget to focus will be self, because this is the widget we want to focus to. And we also don't want to be able to open the inventory. So with this cast to the player controller, we can actually make it a variable to make it easier on ourselves. So we can promote that to a variable and we'll call it player controller ref, and then we can just use that. So let's get the player controller ref, set can open inventory to false, so we can't open the inventory while we're in there. And after all that, we will bind this to the close examination widget. And then if we do close the widget, that's where we want to do all of this. So I'm just gonna create a reroute node here to clean this up. And once again, let's get the player controller, plug these all in. So we want to reset the look input so we can once again look around. We have to replace the show mouse cursor, so set show mouse cursor to false because we don't want to show it anymore, and set the input to game only. And then with the player controller reference, we want to be able to open the inventory, so set can open inventory to true. Alright, so now we can finally test it to see if, oh, one thing is wrong. This target right here, which needs to be our player controller ref. I accidentally unplugged that and forgot to replace it. Alright, so now we should be able to test it out. So when we go into this examination widget, can I move around? No, I cannot. I also cannot look around. The mouse is here. I cannot open the inventory. And if I can click and drag, you can see I can rotate our note, which is wonderful. And then if I hit backspace to get out of it, I have all my abilities again, and I can open the inventory and such, which is great. Turns out the mansion is haunted. Now I know this episode is getting pretty long, but there is one more thing I would like to do before we continue, and that's add more text on the back of one of the notes. So let's go to the Note Master, and let's duplicate our note text. So we'll call this back note text. And what we're going to do is just rotate this -90 on the Y, I believe. Oh, that was wrong. Let's see. Okay, it is -90 on the Y, but also -90 on the X and 0 on the Z. Then we gotta position it correctly on the back side. And let's try X10, and that already looks good. Of course, instead of 0.001 on the Z, we want -0.001, so it's just slightly on the back side. So we can no longer see it on the top, and we can't, and it's hard to see, but it is on the bottom here. Oh wait, actually, I don't believe it is, because it is still kind of in the thickness of the paper, which I believe is 0.1, so instead of 0.001, it should be 0.11. There we go. Yes, now we can see it. Now we need a new variable to set this back note text. So we can duplicate the note text variable. And we'll call this back note text. We'll delete that 0 at the end. And in the construction script, we're just going to do this same thing, but for the text on the back. So instead of note text, it's going to be back note text. And instead of the note text variable, it'll be the back note text variable. The default for the back note text, though, will be empty, so most notes, there will be no text on the back, but you will always have the option to add one if you want. So let's copy the back note text real quick so we can add it in our BP note examination. So let's hit paste. It should be in the correct spot, which it is. Make sure it's a child of the item mesh. And we also have to make sure that's updated as well. So in our W note examination, we have our update widget here. And we have our BP note examination ref and our note text, but now we also have the back note text. So we will get back note text and set text. So we're doing essentially the exact same thing. And the text we want to set is our variable from our BP note master, back note text. All right, I believe that should work. So let's test this out. So let's go into content, blueprints, actors, notes. And on the first note, I'm going to leave it blank. So I'll open that up. And here on the back note text, which has appeared, it should be empty by default, which it is. And then in the second note, I'll change this to our code for the log. And that is how you will find the code in the log. So our back note text will say, oh wait, we don't want to change the text itself. I almost did that again. We want to change the variable here. So back note text will be 9516, which is our code. You can see it on the back right there. So let's test that out. Let's hit play. We can still go see our text right here. Welcome to the Not Haunted Mansion. Well, thank you for inviting me. And then by the time we are in and we find that it's haunted, we have found this box, but we don't know the code. We find this note. Turns out the mansion is haunted. We inspect it. 9516. That's the code, isn't it? It's also important to note that you don't want to get some overlap things mixed up. So I'm actually going to move all these things outside of this overlap sphere because that definitely can make a difference. And very lastly, one more thing you can do to sell the effect is we can choose to hide the note mesh when we're reading it so that it looks like we've picked it up. We can still see it in the back here, but it would be cool if it disappeared when we quote unquote pick it up and then reappear when we put it back down. So if you go into W note examination, we can make a variable from this update widget. So let's just bring all this out just a bit. So the current node actor, we're going to promote it, and we will just call it current note. So which note are we looking at right now, so we know which note to hide. Then when we open the note, after we do all this, before we get to this part, I'm just going to pull this out. I'm just going to say, get this current note, and we're going to set actor hidden in game. Hidden will be true. And then we can just copy and paste this, Command C. And at the end here, we're going to make it revisible once we close the note. So change the new hidden to false. And let's just test that out, hit play. And when we hit E, the note is now gone behind us, and when we go out of it, it reappears. It gives us a much better illusion that we're actually picking up the note. Before we end this episode, be wary of your level design. I already mentioned this, but certain things won't work if they overlap. You have a lot of workarounds, such as making these overlap spheres smaller, just changing your map layout in general, etc. But for example, I think I'm just going to move this over here. The box isn't going to move with it, but just to show you, when it's inside this overlap sphere and we interact with it, it won't always register me trying to click on these widgets here because my mouse is actually interacting with this sphere that I'm already inside and it's stopping it. So you have to be wary of level design. And I'm just going to change this to unlit so I can reposition it correctly. So you'll have to be wary of level design and placement of your objects. So thank you for watching this one. I know it was a long one. A reminder, you don't have to do notes this way. You can do it a much simpler way of just creating a widget that you don't need to rotate or anything. Now you have the option to do either. And I will see you in the next episode. Another thing we want to add to our notes is a widget that shows our text for people who might have trouble reading the fonts on the physical note. You'll see in quite a lot of games where there are notes, there's a little pop-up that says press E to read or whatever, and you press that, and the text comes up in a much clearer fashion just in a UI. But right before we get into that, I want to fix one bug that I didn't realize I came across in the last episode. We can just keep picking up more and more notes if we just keep hitting the E button. You can kind of see on the edges here that it's just stacking on top of each other. And we definitely don't want that. So to fix this, let's go into our blueprints, actors, notes, and BP Note Master. And what we want to do is just make sure we don't create another widget if our widget is already open. So here you see we input action, which is our E button, and we create the widget and add it to the viewport. What we need to do is create a variable from this. So we will drag it off promote variable, and we'll call this W examination note ref. And we're just gonna plug that in like that. And then we can, if you want, just use the variable here to, use the variable here, but it does not make a difference. And then just at the beginning, when we press E, we just want to make sure that our widget does not exist. So we will get an isValid node, get the second one, which is the macro, and we only want to do it if it is not valid. And then we want to set this variable back to nothing once it is destroyed. So we can go into the actual widget, W examination. No, we can just click this little browse button. It'll take us right to it. Open it up, graph, and we have to find the spot where we remove it, which is close examination widget. And after all this, we can get this current note variable, which comes from the BP Note Master, get the variable we just created in here for W examination note ref, and set W examination note ref, and we just won't plug anything in to here, so it sets to null. Alright, and we can test that out now. So if we hit E, we create one. If we hit E again, nothing is happening. And we can close it, and everything works as intended now. Okay, so let's get to the actual point of this episode, which is to create a widget to view the text better. Now, first thing is we have these note texts here, right, that show us what the text on the physical notes say. But these little breaks right here to show us when we want to create a line break, that will not translate onto UI text. It works for this 3D text here, but it won't work in our UMG. So we actually need a new variable for this. So what we want to do is go to BP Note Master. Let's add a variable called widget text. And this is just going to be the text that's displayed on the widget. So this can also be variable type text. And essentially this will just be whatever this text says without the line breaks. We do want it editable, so make sure you toggle that on. And that's all we have to do here for now. So let's go back into W Note Examination. And I want to add a few things to this widget. So we definitely could make the text that comes up a separate widget if we wanted, but it doesn't really make too much of a difference. I'm just going to have it pop up on the same widget. So let's add a button, and the button is going to be called read text button. And let's make the Z order 2 because we want it in front of everything, so we always make sure we can press it. And we need to make sure it's above the drag detection as well, which has a Z order of 1. We can just reposition this somewhere. I'm just going to put it like here in the bottom right. Of course, this doesn't really matter. So I'm just going to get a general idea of where I want it. So negative 720 and negative 300 seems to work. Let's make this 250 by 60. Why not? All right, so let's add some text to this. And let's just have this say read. And I'm just going to make this our Calibri font. Bold, doesn't really matter. Shadow color, and I'll give it a little bit. This is all optional, of course, and you can make this look however you want it. Next, we want a black image to cover everything up to make the text easier to read when the text shows up above the black image. So what we're going to do is just get an image, and we're just going to call this black image. We're going to anchor it to the full screen and make all the offsets 0. And the Z order, we want it to be 3. We want this to be even above the button. Let's make it completely black, and let's make the alpha 0.3, so it's a little translucent. And this will just pop up when the text pops up, so it makes it easier to read. And lastly, we need that text that's going to pop up, so create a text block, and you can just place this wherever you want. I'm gonna put it in the center. I'm gonna make the size something pretty big, like 650 by 800, and then I'll just make the alignment 0.5, 0.5, so I can put the positions at 0, and it is perfectly centered. I might make it a bit smaller, maybe just to kind of fit the size of the note. Yeah, that's kind of cool. So 550 by 400. Okay, and just to see what we're working with a little better, I'm going to take our image here of the note and just hide it real quick so we can see what we're doing. So you can do whatever you want with this, with the font, change it to Calibri, italic, I don't know, something that's easy to see though. And what we want to do is scroll down and turn on auto wrap text. Now this will break the lines for us. That's why we created a separate text variable that will not have the line breaks, because once it reaches the end right here, it'll automatically go to the next line. We also want to make sure the Z order, this one is on the very, very top, and so we'll give it Z order of 4, which is one above the black image. And lastly, we need a way to close the text after we're done reading it, so I will create another button in the canvas panel, give it a Z order of 5, so it's above even the text. I'm going to anchor it to the upper right, and I'm just going to make this 100 by 100, sure. Position X. Let's see, what's the reads position X? It's negative 720, sure. 720, and we're going to bring it down to 320, or 300. All right, and I'm going to make this button have text on it that just has an X. Calibri, like 30 or 45. Probably be better to have some kind of image here, but that's not something we need to necessarily go over right now. And then I'm going to make the button styles invisible, so it's just the X. And I'm just going to call the button close button. And we need to make this black image the note text, or I'll call this, I'll just call it note text. And we want to make it a variable. And this close button, we just want to make them all invisible at the start. So let's search visibility, and we're going to make it collapsed, and close button, collapsed. And now this doesn't show up here in the editor, but we will not see these. And I'm going to turn this back on, so this is what we will see when we open the widget at first. Okay, so we just need to set this note text right here to the correct text right there. So if we go to event graph, in update widget, we just have to get this note text, which I'll just remind you is this one, set text, and the in text will come from this note actor, and it will be the widget text. Because once again, if we just use this note text right here, it would also show the BRs for the line break, and we don't want that. Now let's create on read button. When we click this, so on clicked, or I prefer to use on pressed, we want to get the black image, just making sure it's a variable. And we want to set its visibility to visible. And we want to do the same for this note text and the close button. So note text and close button. And then when we press this, the close button, which is not visible at the moment, when we press this, we want to set these three back to collapsed. So let's test this out. So we have our notes here. So this one says, turns out the mansion is haunted with the line break. So in the widget text, we need to type the exact same thing except to take out the BR. And we'll do that for this one as well. And take out the line break. And let's test this out. So let's just go up to one of the notes, hit E. Turns out the mansion is haunted. Oh, but my poor eyes can't read this text very well. Let's hit read, and this text comes up. Oh, that's much clearer. And then we can hit the X, and we are back to normal. If you also want, just to make it easier, you could easily add some kind of like background blur in between these three and the rest to kind of differentiate. For me, I'm just gonna take our image right here, which we should probably name something, but it doesn't really matter. And when we open the read text, I'm just gonna set the visibility to hidden, and then set it back to visible when we close the button. Just for this case, but of course you are free to go about this however you want. There we go. All right, that's going to conclude this episode. I'll see you in the next one.